Yeah, hi everyone. Welcome to Prefusion. So in this video, we are going to start our new chapter, which is differential equations. So we will start after 2 minutes. I will talk to you guys for next 2 minutes. Best thing about this chapter is that it is completely based on problem solving. The more you practice, the better you become. That's it. There would be concept of hardly 5 to 10 minutes. Then there will be questions. Then again new concept would come 5 to 10 minutes. Then again questions. In that manner, the flow would go on. So it depends highly on the student. Okay, here I cannot teach something new. In calculus, yes, it would depend on the effort of teacher as well, that how he is teaching you. But here hardly it would depend on me. Most of the things would be up to you, that how you study this particular chapter and how much you practice. So now till this point, I don't know how you guys are solving the PYQs. There might be some guys who would say that, sir, I am from EC, I am solving the PYQs of EC only. I am from electrical, I am solving the PYQs of electrical only. Although it is not ideal way. What is the ideal way? Ideal way should be that, sir, we should be solving the PYQs of all the branches. If I am from EC, I will solve the PYQs of instrumentation, electrical, EC, CSE, mechanical, civil, all the branches PYQ I will solve. This is the ideal way. But I don't know what you guys are doing. But for this chapter, specifically for differential equations, I would say you should solve the PYQs of all the engineering branches. Like here, I am putting up the pressure for differential equation. Specifically for differential equation, you will solve the PYQs of all the branches. Because again, I have said the same thing. The more you practice, the better you become. There is no shortcut for this particular chapter. You keep on revising the notes, nothing will happen. It only depends on your practice. Is that understandable to you? So specifically for differential equation, again I am saying we will solve the PYQs of all the engineering branches. Understandable? Okay, then let's get started. Let's start studying about differential equations. So have you seen y equals to fx? Yes, sir. Y is a function of x. What is the meaning of y equals to fx? Y is a function of x. So your independent variable is x. Your independent variable is x. You can put any value of x. X can take value 1, 2, 3, 4, minus 5, minus 3, minus 3.5, under root 2, under root 3. Whatever the value x would take, based on that, y will give you some output. Like y equals to 2x plus 3. So if x is 1, y has to be 5. If x is 2, y has to be 7. If x is minus 1, y has to be 1. Right? So independent variable is x. You are independently taking the value of x. Based on that, you are getting the value of y. So y is known as dependent variable. Okay. Or there is another name, unknown variable. Another name is unknown variable. Okay. Dependent variable or unknown variable, because you don't know the value of y. No. The value of y will depend on the value of x. And if I write down x is a function of y, then x is a function of y. What does that mean? That means, sir, now y will become my independent variable. Y will become independent variable and x will become dependent variable. Understandable? Because here y can take values independently and x value will depend on the value of y that you are taking. Let's just say x equals to y square. So y you can take 1, then x has to be 1. If you take y equals to 2, then x has to be 4. If you take y equals to 3, x has to be 9. Understandable? Very simple thing. Now what is the meaning of dy by dx? How you say dy by dx? So first thing is that whichever that is written on the upper side, whichever that is written on the upper side, that is your dependent variable. That is your dependent variable. Dependent. And whichever that is written on the downward side, that is your independent variable. Say yes or no. So this thing you will remember. Dy by dx. Y is dependent, x is independent. What is the name of dy by dx? It is your first order derivative. First order derivative of y with respect to x. First order derivative of y with respect to x. Array bhai. With respect to x. Say yes or no. Right? What is the meaning of d2y by dx2? That is second order derivative of y. What is the meaning of d2y by dx2? That is second order derivative of y with respect to x. What is the term that you are using? Second order. First order. And what is the meaning of d3y by dx3? Third order derivative of x. Sorry, third order derivative of y with respect to x. Say yes or no. Right? So, sir, what is the meaning of all these things? Why we are writing all these things? We will come back to this point. But let's see the definition of a differential equation. What do you mean by differential equation? So, in the differential equation, there will be an unknown function and one or more of its derivative. That means here you are having first order derivative, you may have second order derivative as well, you can have third order, you can have fourth order, and any order derivative you can have. So this is known as your differential equation. And what is your unknown variable here? Unknown function means y, which is a function of x. Okay, and surely the function of x would also be there, e to the power x is there, so that will also be present. So this is known as your differential equation. What is your differential equation? This is your differential equation. Understandable? Now in what flow we will study this chapter? What will be the flow of our chapter? So first of all we will study order, degree, linearity and formation of a differential equation. This will be our first part. Then we will study first order differential equation, then we will study higher order differential equation, and then we will study partial differential equation. This will be the flow. One by one we will go, everything will be crystal clear to you. So our first target is, forget about everything, our first target is we need to understand the meaning of order, degree and linearity. Order, degree and linearity. So first let's talk about order. What is the meaning of order of differential equation? What is the meaning of order of differential equation? So order of differential equation simply means how much time your function has been differentiated, how much time your y has been differentiated. So maximum time your y has been differentiated, that is known as order. Forget about these powers, only you need to see here sir y has been differentiated only one time. So it is your first order differentiation of y. What is this? This is your second order differentiation of y. Did you understand here why I wrote down first order, second order? So this is your first order differentiation of y, this is your second order differentiation of y. So highest differentiation you have done 2 times only. So what is the order? Order is 2. Let's write down another example. If I write down another example, what I will write down? d3y by dx2. Sorry, d3y by dx3. 3 times you are differentiating. 4 d2y by d2y, अरे भाई क्या कर रहा हूं मैं? 4 d2y by dx2 to the power 3 plus y equals to 0. So does this power 3 matter? No. What matters? Sir, it has been differentiated twice. This has been differentiated 0 times and this has been differentiated 3 times. So what will be the order? Order will be 3. That's it. So this is the meaning of order of a differential equation. Okay. Let's talk about degree. What is the meaning of degree of differential equation? So whenever you talk about degree, no. So first you will talk about order. Do you remember the car, OD car, OD could be written as OD. So if they are asking about degree, no, first you need to think of order. If they are asking about degree, first you need to think of order. So let's just say this equation is given, they are asking the degree of differential equation. So first you need to think of the order. What is the order of this differential equation? Sir, it is differentiated twice. So order of this differential equation is 2. Order of this equation is 2. What is the order? Order is 2. Now sir, what about the degree? So whichever the term is having the maximum order, no, what is the power of that? Sir, power is 3. So answer is 3. Whichever the term is having maximum differentiation, what is the power of that? So how will you read the definition? The degree of a differential equation is the power of a highest order derivative provided the equation is polynomial in its derivative. What is the meaning of this line? That we will see later on. But as of now you only understand the degree of a differential equation is the power of highest order derivative. So first of all you will see what is the highest order derivative. That means what is the order of your differential equation. Sir, order is 2. What is the highest power of it? That is 3. That means order is 2, degree is 3. And order and degree will always be positive integers. You need to remember this. They will be always positive integer. Let me write down another example. d2y by dx2 plus dy by dx to the power 7 plus y equals to e to the power x. What is the order? Will let me know what is the order. Sir, it is maximum differentiated 2 times. What is the degree? Degree is 7? No. Sir, who is maximum differentiated? Which term is maximum differentiated? Sir, this term is maximum differentiated. What is the power of this term? Sir, power of this term is 1 only. So degree is 1. That's it. Okay. So this is the meaning of degree. We will come back to order and degree again, but let's just understand a very simple concept. You will let me know which of the following equation are polynomial in y. What is the meaning of a polynomial in y? What is the meaning of polynomial in y? Basics of equation I am asking you. What is the meaning of polynomial in y? Sir, meaning of polynomial in y, I sir completely understand. It would be a into y to the power n plus b into y to the power n minus 1 plus c into y to the power n minus 2 and so on. Sir, constant value could also be there. The condition is that, sir, all the powers should be positive integer. All powers should be positive integers. This is the first condition. They should be positive integers, right? And what is the other condition? These a, b, c, d, they should not be a function of these a, b, c, d, these should not be a function of y. These guys should not be a function of y. They could be a function of x, they could be a function of z, they could be a function of k, they could be a function of m, n, whatever it is, but they should not be a function of y. Either they are constant or the function of some other variable, but they are not function of y at all. This is the condition of a polynomial in y. So first, is it polynomial in y? Yes, sir. Y cube, y square, y, sir, power is integer, positive integer, power is positive integer, sir, 3, 2, 4, no problem. Here, y cube, y square, sir, x square is there, so what? It is treated as constant. No, this is also constant, this is also constant, and this is also constant, no problem. What about here? Sir, here there is coefficient 1, here there is coefficient 3, here there is coefficient sin x. So what? No problem. Sin y is not accepted, no. Sin y is not accepted. E to the power y is not accepted. Ln y is not accepted. Tan y or sin inverse y is not accepted. These guys are not accepted. Sin x is accepted. It is a constant value. This is also a constant value. Completely it is accepted. But this sin y is not accepted. Right? This under root y is not accepted. Because why is that so? Because power should be positive integer. Positive integer. Under root y not accepted. E to the power x accepted. Sin x accepted. 0. Rest everything is fine. Yes. Ln x accepted. Yes. But this e to the power y is not accepted. E to the power y is not accepted. So did you understand the meaning of polynomial in y? Okay. Understandable? So the degree will be defined if your equation is polynomial in its derivatives. So this time y will be replaced with the derivatives. What does that mean? Let's see this condition. What they are saying? The degree fails to exist if after simplifying the fraction and rational exponents on its derivative. Now ignore this line. Ignore this line as of now. You will understand the meaning of this line in the next slide only. But as of now, what you will read, the degree will fail to exist if any derivative, whether it is highest order or lower order, remains inside the functions, like it is inside the sinusoid or it is inside cosinusoid. What is the meaning of y double dash? Y double dash simply means that you are differentiating y with respect to x 2 times. This is the meaning of y double dash. So if it is inside sine, cos or tan, or it is inside ln, or it is having exponential, or 2 to the power d2y by dx2, or sine inverse dy by dx. If these kind of things are there, no, that means dy by dx or d2y by dx or d3y by dx3, these are trapped inside some other function. They are trapped inside some other function. They are trapped inside some other function. This thing is not acceptable. If this is happening, no, then degree will not be defined. Okay, rule of thumb: a differential equation must be polynomial equation in its derivative for its degree to be defined. If a derivative is in the exponent or inside a logarithm or a part of a trigonometric argument, then it's not polynomial in terms of derivative. Here I will write down an important line. When you talk about degree, y does not matter. Y does not matter. Sir, what is the meaning of this line? You will understand. Have some patience. When you talk about the degree, y does not matter. Let's see that for which of them degree will be defined, and if it is defined, then what is the degree and what is the order. Let's write down everything. Okay. So first of all, you let me know the order. Quickly, you guys will let me know the order. Sir, how much time it is differentiated? Maximum it is differentiated 2 times. Sir, how much time maximum it is differentiated? Sir, it is differentiated 3 times. Order will always be defined. Sir, how much time maximum it is differentiated? Sir, it is differentiated maximum 2 times. So order is 2. So order is very easy. In the examination, if order is coming, no, then you will be happy. Sir, maximum it is differentiated 2 times. Order is 2. Order will always be defined. You just need to see maximum it is differentiated how many times. Maximum it is differentiated 2 times. Maximum it is differentiated 2 times. Order is 2. There you go. What about degree? For the first question, will the degree be defined? Are you seeing any sinusoid, cosinusoid or anything like that? Absolutely not, sir. So maximum it is differentiated twice. What is the power? 3. There you go. Are you seeing any sinusoid, cosinusoid? Absolutely, sir. Dy by dx is trapped inside sinusoid. That means, sir, degree is not defined. Here I will mark it. Degree not defined. If any of the function is trapped inside sinusoid or ln, then degree will not be defined. This is a very important example. Think about it and let me know, will the degree be defined or not? Sir, y is trapped inside ln, no? Y is trapped inside y is trapped inside ln. That means, sir, it is not polynomial in y. Sir, since it is not polynomial in y, then degree will not be defined. Did I say like that? What is written? Highest order or lower order? Here what was written? Polynomial in its derivatives. Here what is written? When you talk about degree, y does not matter. Whatever that is happening with y, I don't care about it. When I talk about degree, whether y is in ln, it is in sin y, it is in cos y, it is in e to the power y, I don't care about it. E to the power y is there, sin y is there, ln y is there, under root y is there, no care. I don't care about it. Degree will be still defined. Degree will say, I don't care about you, y. He is not caring. Are you trapped inside ln? I don't care. But if dy by dx is trapped inside sin or ln, then I will care. Right? But if y is trapped, no, I don't care. So always remember this line. When you talk about degree, y does not matter. So here e to the power x constant because it is a function of x. Here sin x was never a problem for me, no? Because it is a function of x. So e to the power x is never a problem for me. ln y also never a problem for me. Here it is 1. Here power 1 and power 1. So no problem here. Degree will be defined. And what will be the degree? What will be the degree? So degree will be, sir, highest derivative is 2. What is the power of highest derivative? That is 1. Degree will be 1. Next example. Exponential. In the exponential, you are having d2y by dx2. Degree not defined. Okay, so we only care about the derivatives, not defined. We only care about the derivatives, not about the y. Y does not matter. Y will matter when we talk about linearity. Here, y does not matter, but when we talk about linearity, y will matter. So that we will see later on. Is there any problem? So tan inverse x. So what? It is a constant. It is a function of x. It is a constant for me. Phi constant. Phi is a constant. Power 2 is there. Power 1 is there. Doesn't matter. Degree will be defined. What is the degree? Only problem is these guys. Only problem is these guys. That your dy by dx, d2y by dx2, all these should not be trapped inside sin, cos, tan, ln, e to the power y, 2 to the power something, or sin inverse something. Okay? These guys are the problems. Sin inverse x is coming, no problem. Power 2 is there, no problem. Nothing. No issue there. Degree will be defined. What is the maximum power? Maximum power is 1. Will the degree be defined? No. It is trapped inside cosinusoid. So degree not defined. That's it. Okay? So this is the first rule of degree we have studied. First rule of degree. Now there is another rule, but before that, again, okay, directly from here only we will understand the rule. What is the rule? That if your dy by dx or d2y by dx2, these are trapped inside some rational powers like 1 by 2, 3 by 2, or under root, or cube root. If these kind of things are there, no, when the power is not positive integer, it is not a positive integer. When the power is not positive integer, so when the power is not positive integer, then make them positive integer. Okay, not a positive integer, then make them positive integer and then tell the degree. Make them positive integer and after that you tell the degree. Then you tell the degree. Here you will not say, sir, degree is not defined. Degree will not be defined if these guys are present. Sin, cos, inside this, all these things. Okay, but if they are inside under root or power 1 by 2, power 3 by 2, or if this kind of thing is there, no, so then make the power positive integer and then you define the degree. Let's see the first example. What is the first example? So first example is d2y by dx2 equals to 1 plus dy by dx whole square. Till this point there is no issue. 1 plus dy by dx whole square, there is no issue, right? Here there is no issue. Dy by dx whole square, there is no issue here. And then under root. Till this point there is no issue. But sir, this under root is creating the problem. This guy is creating the problem. This under root is creating the problem. So what you can do? Do the square on both of the side. Do the square on both of the sides. So what you will be getting? d2y by dx2 whole square 1 plus dy by dx whole square. That's it. Okay. So what is the order? Sir, it is differentiated maximum 2 times. And what is the degree? So degree, what is the highest power? It is differentiated 2 times. What is the highest power of this? The power of this is 2. Now someone would say that, sir, here you made the square on both of the side. No, what I would have done is that I would have made power 4 on both of the side. If you do power 4 on both of the side, it would become dy by dx2 to the power 4, and it will become 1 plus dy by dx whole square to the power 2, right? So now, sir, what I would say, my order is 2, but sir, my degree will become 4, because sir, what is the maximum power of my maximum differentiation? Power of my maximum differentiation, what is that? That is 4, sir. Power of my maximum differentiation, that is 4. So sir, degree will become 4. Here your answer is 2. So the point is that you need to have the simplest form. Okay, what you need to have? You need to have the simplest form. This is not the simplest form. No, here power 2 is there, power 4 is there. It can get cancelled out. This will become 2 power and this will become 1 power. Simplest form we need to have. Okay, so then you will define degree to be 2. So don't do like that, sir, power 8 I will do, then it will become higher degree. Okay, understandable? Simplest form we need to have. Next, here power 1 by 3 is there, no? Y plus dy by dx equals to d2y by dx2 d2y by dx2 to the power 1 by 3. It is power 1 by 3. So if you need to make it integer power, what you need to do? You need to take power 3 on both of the side. So what I will do? I will take power 3 on both of the side. If I take power 3 on both of the side, what I will be getting? This is what I will be getting. Now, if I need to define order and degree, can I directly define from here? Absolutely, sir. How you can define? Sir, how highest time differentiation twice. What is the power of highest time differentiation? That is 1. That's it. Someone would say, sir, what if you open it up? So what? You open it up. A cube plus b cube plus 3a square b. Does that matter? Does that matter to me? Plus 3ab square. Does that matter to me at all? No, what matters to me? The highest time differentiation. Highest time differentiation twice. What is the power of highest time differentiation? That is 1. That will always remain 1 only. My target was to make the integer powers. Have I made the integer power? Absolutely. Can I define the degree now? Yes. Job done. So you don't need to expand it. Okay. Even if you expand it, then answer will not change. Next, third one. Power 3 by 2 is there. Right? Power 3 by 2 is there. So what I need to do? Here power 3 by 2, here power 1. 1 plus dy by dx whole square to the power. This topic is actually very confusing for a lot of students because they try to study everything in one example only, but you need to break it down. Okay, this is where my role comes into action. I know this topic is very confusing for a lot of students, but I have broken it down completely. Like when the degree will not be defined, when it will be defined, but you need to do some work, and when you don't need to do any work. Like here, you don't need to do any work, directly you can define the degree. Then we studied about polynomial, that what is the meaning of polynomial, and then I told that when it will not be defined because it is not polynomial, that's why it will not be defined. These function will not become polynomial. But one doubt would be there, sir, what about y? Y can do anything. When you talk about degree, we don't care about y. Okay, and then I talked about this thing, that what if the power is not integer? So make the power integer. Understandable? So how will you make the power integer? Multiply with 2 by 3. Will you take power 2 by 3? No, you cannot do it, right? What you will do? You have to take power 6, no? Like 3 by 2, you need to make it integer. 3 by 2 means 1.5. From 1.5 to 3 you can make. That means you will do power 2 here. Are you able to understand this point? What you will do on both of the side, you will take the square. From both of the side, on both of the side, what you will do? You will do the square. On both of the side, you will do the square. And once you do the square, what you will be getting? 1 plus dy by dx whole square to the power 3 would be equals to k d2y by dx2 to the power 3. So this k is a constant, doesn't matter. What is the order? Sir, order, sir, maximum differentiation has been done twice. And what is the degree? Degree would be 3. Right? What is the power? 3. Let's just say if this is the scenario. If this was the scenario, let's just say if this was the scenario, what would have been the order? Sir, order would have been 2. What would have been the degree? Think about it. Let me know what would have been the degree. Sir, sorry, order would have been 3. Sorry guys. Order would have been 3 because it is differentiated 3 times. What would have been the degree? Degree would be 6, right? Why? Because if you open it up, here there is already a square. 1 plus d3y by dx cube, already there is a square, and then you will do power 3 as well. So this has become 3 into 2 power 6, no? Right? Here there is power 6 eventually. This has become power 6 eventually. So eventually when you open it up, this term will have power 6. So what will be the degree? Degree will be 6. Understandable? So this example in your rough notebook you can write down somewhere, or wherever there is space left is, no? Let us say here there is some space left. So you can write down this example, that if d3y by dx3 was there, so what would happen? The power would become 6. So degree would be 6, order will be 3. But here it is very simple. Order is 2. What is the maximum power? That is 3. Next example. Fourth. In the fourth one, what you will do? d2y by dx2 plus under root dy by dx would be equals to x. What is your target? Your target is to remove the under root in the simplest possible way. What do you think? What you need to do? Sir, if I had been at your place, no, sir, what I would have done is that I would have made d2y by dx2 minus x would be equals to minus under root dy by dx. Now on both of the side, I will take the square. Square on both of the side. Square on both of the side. Now if I do the square on both of the side, then my job will be done. What I will be getting? Array y. I need to add a page. d2y by dx2 minus x whole square would be equals to dy by dx. So you let me know what is the order and degree. Think about it and let me know the order and degree. What is the order and what is the degree? Sir, order is 2 because maximum it is differentiated twice. What is the power? Power is 1. No, sir, there is a square, no. So it will be becoming power 2. So degree will be 2. When you open it up, it will become a square plus b square minus 2ab. So d2y by dx2 square plus x square plus 2x d2y by dx2. So what is the maximum power of d2y by dx2? That is 2. Maximum power of d2y by dx2. That will be 2. So degree will be 2. Okay. Fifth example. Here there is power 1 by 2. Here there is power 1 by 3. d2y by dx2. Power 1 by 2 is there. And dy by dx plus 1 power 1 by 3 is there. What do you think? What we need to do? Which power you will take? Sir, if I take power 2 here, what I will get? Here I will become power 1, but here the power will become 2 by 3 only. If I take power 3, this will become 1, but this will become 3 by 2. Then also there is problem. If I take power 4, this will be 4 by 3, 4 by 2. So this is a problem. If I take power 5, 5 by 3, 5 by 2, again problem. If I take power 6 on both of the side, if I take power 6 on both of the side, what will happen? 6 by 2 will become, if I take power 6 on both of the side, power 6 I am taking. So what will happen? d2y by dx2 power 6 if you are taking, this will become power 3, and dy by dx plus 1, this will become power 2. So what is the order? Sir, order, sir, it is maximum differentiated twice. What is the degree? Degree is 3. Right? Why degree is 3? Because, sir, what is the power of maximum differentiation? Power of maximum differentiation is 3. Tell the answer of this question. Do I need to change it? Do I need to change it? First of all, you let me know, will the degree be defined? Yes, sir, there is no issue. Sin x, no problem. No problem here, no problem here. And do I have the problem here? No. Why is that so? When we talk about degree, we don't care about y. Whether you are in under root, you are having power 1 by 4, power 1 by 7, I don't care about you. Power 1 by 7, power 1 by 9, you are having e to the power y. I don't care about y. I only care about your derivatives when I talk about degree. So no changes required. No changes required here. No changes required. Again and again, I am repeating the same line. When we talk about degree, we don't care about y. Whatever that is happening with y, I don't care. Y is coming in exponential, it is coming with 10, it is coming with under root, it is coming with power 1 by 7, 1 by 9, minus 3 by 7. Whatever it is, I don't care about it. I only care about these guys. When I talk about degree, I will only look at these faces. This face I will look at, this face I will look at. That's it. So these faces are looking good for me. That's it. What does that mean? That means, sir, order is 2, degree is, order is 2 and degree is What is your degree? Degree is also 2 because it is being differentiated twice. Maximum it is differentiated twice. And what is the power? Power is also 2. So order 2, degree 2. That's it. Understandable? So sixth example was also pretty good. So every example that we have seen, no, from these examples only question will be framed. A lot of students often struggle in this particular topic, but we have seen it in a very convenient way, starting from orders, maximum differentiation. That's it. Then degree, power of maximum differentiation. Always it will be integer. When it will not be defined, when they are coming in sinusoid, cosinusoid, tan, e to the power y, e to the power e to the power y, e to the power dy by dx, or 2 to the power dy by dx, sin inverse dy by dx. But y does not matter. Y can take anything. Ln it can take, e to the power y it can take, sin inverse y it can take anything. So this is the scenario. Okay. So degree, here degree will not be defined, here degree will not be defined, here degree will not be defined, otherwise it will be defined. There would be an issue of non-integer power, then make them positive integer. How will you make them positive integer? By doing the squares and all in you using your brain. But we need to take the simplest form. Simplest form we need to take, that means the minimum power we need to take. So here on both of the side I took power 3, here I did the square, here I took the power 2, here I took power 2 as well, here I took power 6. Understandable? So this is how we need to understand. Next we will talk about linearity. What we will talk about? Linearity. So let's talk about linearity, but first we will talk about y. So which of them is a linear equation in y? Think about it and let me know. Is it linear? Absolutely. Is it linear? Sir, x square is there, no? So what? X is a constant. Y has to be linear. No, what is the meaning of linear equation? Ay plus b equals to alpha, anything. This could be a function of x, yes. This could be a function of x, yes. I don't care. I only care about one thing, that y should have maximum power 1. The maximum power of y should be 1. Maximum power, this could be also a function of x, yes, it could be a function of x. Y, maximum power of y should be 1. What is my matter of concern? Maximum power of y should be 1. Maximum power of y should be 1. Y should be 1. And y should not be trapped inside anything. Like y should not be trapped inside anything like sin y, no. E to the power y, no. Under root y, no. Right? Maximum or minimum, like power of y should be 1. When we talk about linearity, power of y should be 1. Linear equation means power of y should be 1. I should not say maximum power of y should be 1. Power of y should be 1. And it should not be trapped inside anything. Ln y not accepted. Understandable? So it is trapped inside under root. Not accepted. But this is accepted. Y is having a power of 1. Sin x constant, x square constant. Is this accepted? Absolutely not. Because sin is trapped inside y. Sorry, y is trapped inside sin. Not accepted. Is it accepted? Ln x plus e to the power y. Ln x is accepted, but this e to the power y is not accepted. This is not accepted. This is not accepted. This guy is accepted. This guy is not accepted because e to the power y is there. Now think about this one. Last, sixth. Y sin x, no problem. X square, no problem. 4x minus 3, no problem. It is a function of x, no problem. This sin x, no problem. I only need to care about y. The power of my y should be 1. And it should not be trapped inside anything. That means this is accepted. And this is accepted? Absolutely not, because power of y is 2. Power of y is 2. Basically, it is y multiplied with y. Y multiplied with y. So that's why there is a problem. So y will say that I will come alone. With me, some constant function can come, some function of x, some function of z, anything can come, but function of y should not be there. Like y multiplied with the function of y, there is an issue. And my maximum power should be 1 only. Maximum or minimum, my power should be 1 only. That is the meaning of a linear equation in y. What is the meaning of linear differential equation? So here are the rules. The rule will say that they should have the maximum power of 1. That means dy by dx. And when we talk about linearity, y matters. When we talk about linearity, y will also matter. When we talk about linearity, y also matters. Y also matters. Okay. So here y dy by dx, d2y by dx2 all will follow the same rule. What is the scenario? The scenario is that their maximum power should be 1. Their maximum power should be 1. Maximum power should be 1. Maximum power should be 1. In the multiplication, There could be anything. Function of sinusoid x cube e to the power x ln x. There could be anything. I don't care. But they should not be multiplied together. That means y should not be multiplied with dy by dx. Dy by dx should not be multiplied with d2y by dx2. That means it is a function of y. Multiply with the function of y. Function of y multiply with the function of y. This is something that I told you, no? Function of y multiply with the function of y. That is not acceptable for me. Y alone should be there. That means dy by dx alone should be there. d2y by dx2 alone should be there. Y alone should be there. With me, function of x could be applied. With me, function of x can be multiplied. I don't care. With me, function of x could be added as well. I don't care. Anything about x, I don't care. But y multiply with y, that is the problem for me. And they should not be trapped inside anything. So when you think about linearity, think about the linearity of y. What is the linearity of y? Linearity of y will say that, sir, y should be coming with the power 1 only. It should not be multiplying with any function. It should not be trapped inside any sinusoid or cosinusoid. That's the concern. So now you talk which of them is linear, which of them is not linear. Sir, alone they are coming, alone this is coming, alone this is coming. Sir, sin x is there. Is that a problem for me? Absolutely not. E to the power x, is that a problem? No. X cube problem? No. Yes, it is a linear equation. What about these guys? Sir, d2y by dx2 power 1 is there, no problem. Y multiply with dy by dx. Function of y multiply with function of y, problem. dy by dx to the power 2, problem. Under root y, problem. Because I told you y matters. Y matters. Y life matters. Okay, y matters. So under root y, problem. Right? Here you would have been written. Under root y is a problem. Cos y is a problem. Cos y is a problem. Is there any problem here? So d2y by dx2, no issue. Multiply with ln x, who cares? It is a constant. Y multiply with e to the power x, who cares? Constant. This is also constant, no issue. X multiply with dy by dx, who cares? Function of x could be multiplied, y could be multiplied, but here there is issue. Dy by dx is trapped inside sign. Is there any problem here? This time I have changed the variable, no? You see this thing. dxy dy plus function of y dot x function of y. So this time x has become dependent. Just opposite thing I have done. Okay, in place of x I have put y. That's the thing I have done. This has become dependent and this has become independent. Y is independent now. So the guy who is dependent, he should come alone. X will say that I will come alone. With me there is y, no issue. With me there is y, no issue. So no issue. But x multiply with the derivative of x, that is not acceptable. This is not acceptable. X multiply with sin y, acceptable. Dx dy multiply with ln y, acceptable. Okay, understandable. So just I change the variable. Now x is y is x. They are just interchanged. I hope you have understood the meaning of linearity as well. This is also very confusing for the students. So what we have studied: order, degree and linearity. How to determine if the differential equation is linear or not. So let's revise everything, whatever that we have studied till this slide. Okay, order, understood. Degree, when is the problem with the degree? The problem with the degree is that, sir, if my dy by dx, d2y by dx2, if they are trapped inside some sinusoid or cosinusoid, sir, then there is a problem. So degree will not be defined. Sir, there is one more problem. If they are coming in the radicals, like power 1 by 2 is there, 3 by 2 is there, under root is there, cube root is there, then I will remove them by doing the squares and all, and then I will define the degree. What about linearity, sir? Linearity will say one thing only. What linearity will say? Linearity will say that my y dy by dx, d2y by dx2, they will come alone. They should not be multiplied with the function of y. So they will be coming alone. This is the first point. Their power should be 1. Power should be 1. Like they are coming alone. If power is 2, no, d2y by dx2 power 2. What does that mean? That means d2y by dx2 is multiplied with d2y by dx2. That means function of y is being multiplied with the function of y. So that is not possible, no. That means second point and first point are same only. Maximum power should be 1 or they should not be multiplied together. Both are the same thing. And they should not be trapped inside some sinusoid e to the power y or ln y dash or sin inverse y dash. They should not be trapped inside anything. Understandable? But x can do anything. We don't care about x. X is a independent variable which will be like a constant for us. It can do anything. We don't care about x. Whether it is about degree or it is about linearity, we don't care about x. The only change in the linearity is that in degree if there is under root, no. When you define the degree, if there is under root, it is acceptable. When there is under root, when there is power 2 by 3, when there is power 4 by 3, that is acceptable. But when we talk about linearity, strictly the power has to be 1. Here, y being trapped, not acceptable. But for the degree, is it acceptable? Yes, degree will be defined here, no? What will be the order and degree? Here degree will be defined. Order will be 2, degree will be 1. Order will be 2 and maximum power degree will be 1. Now let me know, here the degree will be defined. Absolutely. What is the order? Order will be 3, degree will be 1. Order will be 3, degree will be 1. So here also order and degree will be defined. What about this guy? When you talk about degree, you do not care about y. When you talk about degree, you do not care about y. So here also order and degree will be defined. What is the order? Order will be 2 and degree will be 1. What about this guy? What is the order? Order and degree are defined. When you talk about degree, you don't care about y, no? So yes, order will be 2 and degree will be 1. Degree will be defined, absolutely. Order will be 2, degree will be again 1. And it is pretty obvious, no? That for the linear differential equation, degree has to be 1 only. If the equation is linear, then maximum power will be 1 only. The maximum power of dy by dx, dy by dx, that would be 1 only, no? So degree has to be 1 only, which is pretty obvious. Here, degree defined, not defined. Degree not even defined. Degree not defined. Why is that so? Because dy by dx is trapped inside sign, not defined. Not defined. Degree is not defined, along with that it is non-linear as well. Understandable? What about the first example? Yes, it is linear, degree is also defined, everything is defined, degree is 1, order is 2. Understandable? So all these things, everything is crystal clear. Just revise it, whatever that we have studied, and whatever the confusion that you always had in this particular topic, that is gone now. Say yes or no. Your confusion is gone. Absolutely, it is gone. The confusion that you are having in these kind of questions, that is absolutely gone, sir. Now, I don't have any confusion in this particular topic. Okay, and there are very high chances you would see that nowadays almost every year they are framing some question from degree or linearity or like whatever the discussion that we have done now in those 45 minutes. From those 45 minutes only they are framing the questions nowadays, because they also know that people actually struggle here. They don't remember degree, linearity, everything they mess up. But we have studied them separately, so everything is clear to us. Absolutely everything is clear. Understandable? Let's go to the formation of differential equation. How do you frame a differential equation? So you don't need to read all these things. The bottom line is y equals to a cos x plus b sin x is given. We need to find out the differential equation like d2y by dx2. This kind of equation we need to frame. So how we will frame this equation? So you need to count the number of constants. How many constants are there? 2 constants are there. So number of constants equals to the number of differentiation you need to do. This is the important line. Number of arbitrary constant would be equals to the number of times you need to differentiate the equation. So let's make the differential equation. Y equals to a cos x plus b sin x is given, no? Y equals to a cos x plus b sin x is given. So 2 constants are there. So what we will do? We will differentiate this twice. So what is dy by dx? So dy by dx I am getting as minus a sin x plus b cos x. One more time I will differentiate d2y by dx2. What I am getting? So I will get minus a cos x plus b sin x. Right? Now some relation you would be getting. What relation are you getting? Some relation would be there for sure. Right? What relation is there? That we are not able to see now. Arey bhai, this would be minus sign, no? Right? Minus a cos x minus b sin x. Right? Differentiation of cosinusoid will be minus sign. So you take minus sign common, what you will be getting? A cos x plus b sin x. Right? Now what this is equivalent to? A cos x plus b sin x. So that is equivalent to y only. So what you are getting? d2y by dx2 is coming out to be minus y, or you can write down d2y by dx2 plus y equals to 0. There you go. This is the differential equation that you are getting. So how to frame the differential equation from the given relation? Y is given as a function of x. Y is given as a function of x. What you need to do? You need to frame the differential equation. How will you frame it? Sir, by doing the differentiation. Two constants are there, so 2 times differentiation I will do and I will get the answer. Let's see more questions. This question is given. This is a very good question. What you need to find out, the order of differential equation corresponding to the family of curves. That means this particular relation is given, y equals to fx is given. When you frame the differential equation, what will be its order? This is what they are asking. When you frame the differential equation, what will be its order? This is what they are asking. So sir, there are 3 variables, 1, 2, 3. So sir, there are 3 variables, a, b, c. 3 variables are there. No, sorry, not 3 variables. Sorry guys, there are 3 constants. Sorry guys, there are 3 constants. So sir, there are 3 constants. So sir, order will be 3 and this answer is wrong. Okay, very good level of problem. Nowadays, what I feel is that this kind of question could be coming in your examination. So this everyone studies that number of constants would be the number of times you need to differentiate. So if I am differentiating 2 times, that means, sir, the order will be 2 and order is always defined. So order has to be 2. Here, sir, there are 3 constants. So that's why, sir, order should be 3 because I will differentiate 3 times. A cos square x plus b sin square x. Think about it. Can I write down cos square x as 1 plus cos 2x divided by 2? Absolutely. Can I write down this 1 minus cos 2x divided by 2 plus c? What I will be getting? A by 2 plus a by 2 cos 2x plus b by 2 minus b by 2 cos 2x plus c. What you are getting? A by 2 plus b by 2 plus cos 2x a by 2 minus b by 2 plus c. Isn't it a constant itself? A by 2 plus b by 2 plus c. Isn't it a constant itself? Absolutely, sir. It's itself is a constant, right? A by 2 plus b by 2 plus c. It's itself is a constant which will be k1 plus, isn't it a constant together? K2. Yes. K2 cos 2x. How many constants do you see here? 2 constants only. Now I cannot reduce it further. 2 constants has to be there. But reduction is possible. No, always try to reduce whenever sinusoid cosinusoid functions are coming. No, so try to reduce it. This is the reduction that we have made. Where what is k1? K1 is the linear combination of a by 2 plus b by 2 plus c. That is your k1 and this is your k2. Reduction is possible. Right? Now frame the differential equation. 2 constants are there, so you need to differentiate twice. So dy by dx, what you are getting? 2k2 sin 2x with the negative sign, and then d2y by dx2 minus 4k2 cos 2x. Say yes or no? Right? So what we can do now? Y minus k1 I can replace k2 cos 2x would be y minus k1. And then how will I get rid of k1? K1 will be present only. Yes. What you do is that you divide equation 1 by 2. No. Our target is that in our differential equation, there could be a term of x, like there could be a term of x, there could be a term of y, everything could be there, but there are no constants available. No. Our target is that there should not be any constant available. This is our target, right? There should not be any constant available. This is the target. Constant should not be there. That means k1, k2 should not be there. K1, K2 should not be there. This is my target. So what I will do? I will divide the equation 1 by 2. What I will be getting? If I divide, or if I will divide the equation 1, I will divide the equation 2 by 1. So what I will be getting? d2y by dx2 divided by dy by dx would be equals to, this k2 will get cancelled out. This will become 2 tan 2x dy by dx. That's it. This is the equation that you are getting. Simply do the division, you will get the answer. No, divide the equation 2 by 1. That means what you will be getting? I am writing d2y by dx2 as y double dash, dy by dx as y dash. This is your y dash. Y dash means y is differentiated 1 times. Y double dash means y is differentiated 2 times. That would be equals to, minus minus sign will get cancelled out. 4 divided by 2 would be 2. K2 will get cancelled out. cos 2x divided by sin 2x will become cot 2x. Sorry guys, it will become cot 2x. Cot 2x. So it will become cot 2x. That's it. So y double dash would be equals to 2 cot 2x y dash. So function of x could be there, dy by dx could be there, d2y by dx2 could be there. So yes, this equation is acceptable. Okay. So this is how we need to frame. So what is the order? Order is actually, from here only I can say that order will be 2. If I need to tell the answer, I can tell the answer from here, sir. No further reduction is possible. Order will be 2. Understandable? It was a good question. Usually from this particular topic questions are not asked, but this kind of question could be asked, that they can ask you the order. How will you define the order? This is how I will be defining the order. Okay. Now we will study solving the differential equations. Now through the whole chapter, no, we will always solve the equation of degree 1 only. Always our degree will be 1. What is the meaning of that? That sir, always you will get d2y by dx2, or sir d3y by d3y by dx2. All these things you will never get their power 2, power 3. Always degree will be 1. So from now onwards I will say first order differential equation. I will not even talk about degree. Degree will be 1 only always. Whenever we talk about it, we will always talk about degree 1 only. So what I would say, first order differential equation. Now if I need to talk about these guys, d2y by dx2, then I will say higher order differential equation. First order, higher order. If the order is 2, then higher order. What is the meaning? If order is 1, then first order equals to 1. If order is 1, then first order. And if order is greater than 1, then higher order. If order is greater than or equals to 2, then higher order. Okay. So first order differential equation, higher order differential equation, always the degree will be 1 only. Degree will be 1 only. So how to solve these equations? That we need to see. Okay. So that we will see after a break. So first method is variable separation method. That means your brain. Variable separation method means your brain. What do you mean by brain? Sir, it is given as x dy minus y dx. I can write down as x dy equals to y dx. So what is dy by dx? So dy by dx is given as y by x. So this was your differential equation. This was the differential equation that was given. Dy by dx equals to y by x. So what I can do? Can I make it like this? Dy by y would be equals to dx by x. So it is simply 1 by y dot dy equals to 1 by x dot dx. Can I do integration on both of the side? Yes, sir. X dy minus y dx. Sir, I separated it. Y I took aside. 1 by y dy, 1 by x dx. I am doing the integration on both of the side. What is the integration of 1 by y? Ln y. What is the integration of 1 by x? Ln x. Plus some constant value. Whenever you integrate, you put up a constant value. No, this time I am putting the constant as ln c. Or you can simply put c as well. Let's put the constant as c. So what answer you will be getting? Sir, this is what we are getting after integrating. So sir, from here ln y minus ln x equals to c. From here I can write down, I can reuse the property ln y by x equals to c. So from here what I am getting, y by x equals to e to the power c. So what is e? E is some 2.7 point something to the power c, which is a constant value. Constant to the power constant will come out to be a constant only. So this will be a bigger constant. So what you will be getting, y by x equals to constant only. Which property we have used here? Ln a minus ln b, which will be ln a by b. So ln y by x equals to c. This ln goes here, it will become e to the power c. So y by x equals to some constant. So what you are getting, y equals to, let's say that constant is m. That constant is m. E to the power c I am putting as m. So y equals to mx. What is this? This is the equation of straight line. So it will represent a family of straight line. So in the examination, what they would ask, x dy minus y dx, what this represent? So what will be your answer? Family of a straight line. What is the meaning of family here? Because sir, m can take any value, no? If m is taking value 1, then this is the equation, then this is the line. If m is taking value 2, then sir, this will be the line. If m is taking value minus 1, then this will be the line. If m is taking value 3, then sir, this will be the line. So a lot of lines are possible. So family of lines, what it is known as family of a straight line. So these kind of very straightforward question could be asked, that they will give the equation x dy minus y dx equals to 0. What this represent? What this differential equation represent? It represents the family of straight lines. This will be the answer. Understandable? Very straightforward question. Again, you just need to use your brain, nothing else. X dy plus y dx. What you will do? X dy plus y dx. What it will represent? So solve it. Sir, x dy equals to minus y dx I can do. Sir, I need to take x aside and y aside. So can I do in this manner that sir y goes downward, so it will become minus 1 by y dy, and sir x goes downward, it will become 1 by x dx. Both of the side you do the integration. On both of the side you do the integration. That's it. What you are getting? Here I am getting minus ln y would be equals to ln x. Let's take a constant as ln c, because ln2 is a constant value, ln3 is a constant value, right? ln is just a function, no? So I can take the constant as ln c this time. Why I am taking ln c, you will understand. So what I will do now, let's take this one aside. So it will become ln c equals to ln x, and this is coming this side. Minus ln c would be equals to ln x plus ln y. So what you are getting? Minus ln c would be equals to ln xy. So this is just a constant value, right? So let's call this as c1. Let's call this as c1. So minus ln c1 can I write down as ln c? So I can simply compare them. What is the answer you are getting? xy equals to c. This is the answer that we are getting. Xy equals to constant. And what is this is? This is the family of a hyperbola. Hyperbola. So actually this is a gate value only. X dy plus y dx equals to 0 will represent the family of hyperbola. From now onwards, there is something special about this guy, x dy plus y dx. If I ask you to differentiate xy, what will be the answer? You need to differentiate the function xy with respect to t. What will be the answer? Sir, x as it is, differentiation of y, plus y as it is, differentiation of x. So can I write it down in this way? X dy plus y dx divided by dt. And what this is coming out to be equals to? So it is coming out to be equals to d by dt of xy. So can I write it down in this way? D of xy divided by dt. That means dt get cancelled out. dxy is coming out to be equals to x dy plus y dx. You will always remember it. D of xy would come out to be equals to x dy plus y dx. So directly how I could have solved it? Sir, x dy plus y dx is nothing but dxy would be equals to 0. Both of the side you integrate. What answer you will be getting? What is the meaning of integration d? They will cancel out each other, no? So what you are getting? xy. Integration of 0, constant. There you go. This will be the answer within one line. If you remember x dy plus y dx, there is no shortcut for x dy minus y dx. Always remember, x dy minus y dx does not represent anything. Although it is a straight line, but you got it after the calculation. But sir, there is a shortcut for x dy plus y dx, that is nothing but dxy, which will represent xy equals to c. Understandable? You will remember this particular line. dxy would be equals to x dy plus y dx. Understandable? And this also you will remember that integration and d will get cancelled out each other. Okay. Next, variable separation you need to apply. How will you apply variable separation? If you look closely, dy by dx is given as e to the power x plus x square, e to the power x plus x square. What I am taking common? I am taking common e to the power minus 2y. From here e to the power minus 2y I have taken common, e to the power minus 2y I have taken common. Now what I can do? Let's take this e to the power 2y downward. dy would be equals to e to the power x plus x square dot dx. Now this is 1 by e to the power 2y, 1 by e to the power minus 2y. It could be written as e to the power 2y dy. Say yes or no. Now on both of the side, what I will do? I will integrate. Can I do the integration? E to the power 2y by 2. What is the integration of e to the power x? That is e to the power x only. What is the integration of x square? That will be x cube by 3 plus c. That's it. Okay. So whenever you have written plus c, no? So this c can take any value. So this is known as general solution. What this is known as? General solution. Now if c is taking a particular value, c equals to, let us say I am putting c equals to 1, some particular value I am defining, c equals to 1, some particular value, because c is a constant, no, it can take any constant value, but I am defining some particular value, c equals to some particular value I am defining. So what will be my equation? This will be the equation I will be getting. So what this is known as? This is known as particular solution. Okay, this is known as particular solution. Under some condition your c equals to 1, so that's why it is known as particular solution. Understandable? Try solving this one. After that, try solving this one as well. Try solving this question as well. And yeah, that's it. Then we will study about exact differential equation. Try solving these questions on your own. Try solving this one, 4th, 5th, and then 6th question. These 3 questions you try solving on your own. You should be able to solve it, and then we will study about exact differential equation. Let me take a break. I will drink some water and then I will come back. Yeah, welcome back. Just there is a change in the t-shirt. Rest everything is same. I am the same person. Yeah. So did you try this question? What you will do? You will take all the elements of y this side and then dx this side. Like you cannot keep dx and dy in the denominator. No, I hope you are able to understand. Like let's just say if I am doing x into 1 by dx, x into 1 by dx, will that make any sense? No. So dx and dy should be in the numerator only, right? That's a very simple thing. So y plus 1 divided by y I will take here. So all the elements of y are here. All the functions of y are one side, and all the functions of x also one side I will expect, and dx I will take to the other side. Dx I will take to the other side. What I will do here, I will add 1 and subtract 1, right? It is x, no? So what I will do is that I will add 1 and subtract 1. Why is that so? Why I am doing so? Because this is becoming, sir, 1 plus 1 by y dot dy, and this is becoming 1 minus 1 by x plus 1 dot dx, and both of the side what you do, you integrate. So what is the integration of dy? That would be y. What is the integration of 1 by y? That would be ln y. What is the integration of dx? That would be x. What is the integration of 1 by x plus 1? That would be ln x plus 1 plus c also I can do. Simple integration. X minus ln x plus 1. Simple integration. Y plus ln y. Right. So what will happen is that I will take this ln y plus ln x plus 1 here. Right. That would be equals to x minus y plus c. So what answer you are getting? Ln x plus 1 into y, because ln a plus b I am applying. So ln x plus 1 into y would be equals to x minus y plus c. So this is the possible answer. You can take ln to the other side as well. Exponential answer you can write down. Basically this answer also you can write down. No, y into x plus 1. Ln I am taking to the other side. It will become e to the power x minus y, and then e to the power c will be another constant. So that I am writing as k. E to the power c I am writing as k, because e to the power c will also be another constant, no? So this could be the possible answer. So this is the possible answer that we are getting. Understandable? So simple thing is there, just variable separation. Like x aside, y aside. If this thing we are able to do, then we are able to solve the question. This is the first method, very straightforward. These kind of questions we used to solve in class 12th as well. Understandable? Right? So let's go to the next question now. This question. Here good concept of integration would be used. Good concept of integration. Otherwise this is straightforward. What will happen here? Sir, all the functions of y I will take aside, and all the functions of x I will keep aside. So if I take sec y this side, what I will get? 1 by sec y e to the power minus y dot dy would be equals to what? E to the power x into 1 plus x. E to the power x into 1 plus x dot this dx I am taking this side dot dx. Right? What I will be getting here? 1 by sec y will be what? Cos y. E to the power minus y will be e to the power y dy. Here also I will do integration only. Now e to the power x plus x e to the power x dx. Now without even looking at your notes, do you remember this formula? Without looking at your notes, what is the integration of e to the power ax cos bx? Do you remember this formula or not? Without looking at your notes. Sir, the formula was e to the power ax upon a square plus b square, a cos bx, b sin bx. Angle is bx only, angle will always remain bx only. First what will happen? A cos bx would come, and then b sin bx would come. Sir, whenever we talk about integration, sinusoid will always be positive. There you go. This is the formula. Right? So what will be the answer here? A to the power y divided by 1 square plus 1 square will be 2. 1 cos y plus 1 sin y would be equals to, can you do the integration of e to the power x? Sir, that would be e to the power x only. Can you do the integration of x e to the power x? Absolutely, sir. What will be the integration of x e to the power x? Sir, that would be first one as it is, integration of second minus differentiation of first, then integration of second, and then full integration. This is the answer you will be getting. All these things in the basics of integration we have studied. Single integration. These things you should be able to do. This and this will get cancelled out now. E to the power x, e to the power x will get cancelled out. What answer you are getting? E to the power y cos y plus sin y, along with that plus c would also be there, would be equals to, what will happen? 2 will go this side, so that will become 2x e to the power x plus some constant c. So here you write down k, 2 into k will become another constant, like this is k, that will be multiplied with 2, that will be another constant, no? So this is the answer that you will be getting. That's it. Okay, yeah. This is the answer that we are getting. Understandable? So simply you do the integration, take this aside, e to the power x, e to the power x is getting cancelled out, 2x e to the power x plus c. Okay, so this is the answer that you are getting. Next question, try doing it on your own. What is the meaning of this, sir? X 0, 0.5, what is this? Look, x is a function of t, no? What is your x? X is your dependent variable, right? X is your dependent variable. And t is your independent variable. From here you can see, no? T is your independent variable. So from here, sir, I am pretty sure that x will come out to be a function of t. That's for sure. So if this is written, no, x bracket 0, what does that mean? X bracket 0, that means x of t is defined as x only. What does that mean? X bracket 0, 0.5. What does this mean? That means at t equals to 0, this is the value of t. At t equals to 0, the value of x is 0.5. This is what they are saying. And now you need to find out this particular thing. What does that mean? That means you need to find out at t equals to 1, what is the value of x. So do you understand the meaning of this x bracket 1? If y bracket x is written, what does that mean? That means that when the value of x equals to x, then the value of y. If I write down y 2 equals to 3, what does that mean? When x is 2, the value of y is 3. Understandable? Because if y is a function of x, then this is how it could be written. If y is a function of x, then this is how your y could be written. Is that clear or not? So whatever that is inside the bracket, that is the value of t, and whatever that is written here, that is the value of x. So that's why I am saying that x of t is defined as x. That means x of 0 is 0.5. If value of t is 0, then value of x is 0.5. Understandable? So now what they are asking, if value of t is 1, then what is the value of x? This is what they are asking. Okay, let's get started. Variable separation, sir, I can directly see. What I can see? dx by dt is given. So dx, गर्मी बहुत लग रही है भाई. dx, this will come downward. X into 1 minus x would be equals to dt. Here what I need to do? I need to do the partial fraction. How will I do the partial fraction? Can I do the partial fraction in this way? 1 upon x plus 1 upon 1 minus x dot dx. Is that correct? 1 minus x plus x will be 1. Yeah, this is correct. Would be equals to dt. Both side integration you do. Yeah, sorry for the interruption. So where were we? 1 by x. So what is the integration of 1 by x? That is ln x. Integration of 1 by x is ln x. And what is the integration of ln 1 minus x? What is the integration of 1 upon 1 minus x? That is minus ln 1 minus x. Okay, a lot of people will write down plus ln 1 minus x, but there will be negative sign as well, no, because this is minus x. So in differentiation of minus x will be minus 1, so there will be a negative sign as well. That would be equals to t plus c. So from here what you will be getting? You will be getting ln x upon 1 minus x equals to t plus c. So from here what you will see, x upon 1 minus x would be equals to e to the power t dot e to the power c, right? E to the power t plus c it would be, so e to the power t dot e to the power c. Now e to the power c could be another constant which is k. So x upon 1 minus x k e to the power t. When t equals to 0, then x is equals to 0.5. When t equals to 0, then x equals to 0.5. When t equals to 0, x equals to 0.5. When t equals to 0, x equals to 0.5. When t is 0, x is 0.5. So I am putting x equals to 0.5, putting t equals to 0. So what this will become? Sir, k into 1, 0.5 divided by 0.5. So what value of k is coming out to be? 1 only. So value of k is 1. So this was your actual equation that we got. But sir, from the given condition, when t is 0, we got that value of k has to be 1 only. Because when t is 0, x is 0.5. So when t is 0, x is 0.5. So from here, I got that value of k has to be 1 only. So if the value of k is 1, then what is the value of then what is the equation that I am getting? So this is the equation that we are getting. Now what they are asking? They are asking that when the value of t is 1, then what is the value of x? This is what they are asking. So x upon, this is 1 minus x, x upon 1 minus x, x upon 1 minus x equals to e. This is what they are asking, right? So from here you need to find out the value of x. So x would be equals to e minus ex. So x plus ex equals to e. From here x into 1 plus e equals to e. So value of x is coming out to be e upon 1 plus e. E upon 1 plus e. So this is the value of x we are getting, e upon 1 plus e. So 0.731. So the population is coming out to be 0.731. So what could be the error here? Here the error could be that, sir, this integration I can mess up. Here negative sign, if you mess up, then whole question will be messed up. So simple thing were given, all the values were given, t equals to 0, x was 0.5, t equals to 1, you need to find out the value of x. We got the equation, so this is the equation that we got. Now in this equation we need to put up the condition that this is given. So I put this, t equals to 0, x is 0.5, so value of k is coming out to be 1. Here I put it. Now I need to put t equals to 1. What is the value of x that I am getting? That I got 0.731. Understandable? So 0.731 is the answer. Let's go to next concept. So variable separation is clear, sir, right? It will be clearly visible in the questions. Here it is clearly visible that, sir, x can come aside, t can come aside. Here also it is clearly visible that, sir, y can come aside, x can go aside. Here as well, x can come aside, y can go aside. So everything will be clearly visible when it is about a variable separation method. Okay. Now what is the equation that we are solving? How we started? From where we started our chapter? We started our chapter from, or we started our topic from order 1 differential equation, right? The differential equation should have the order 1 and degree also 1. So order 1, degree 1. Then how the equation will look like? So the equation will look somewhat like this: dy by dx equals to some function. Let's just say the function is written as m by n. What is the meaning of m by n? Sir, m will be a function of x comma y, and n will also be a function of x comma y. This is also a function of x comma y. So this is how it is written. This is what we are assuming with the negative sign. This is what we are assuming, that this is how our equation is written. So when we rewrite the equation, can we rewrite in this manner? I am rewriting this guy. So it will be n dy would be equals to minus m dx. Now this m dx come this side, m dx plus n dy equals to 0. So in the examination, in place of giving dy by dx, it might happen that they are giving you this form. So if they are giving you this form, then what you would understand that, sir, it is first order differential equation only. It is nothing but a first order differential equation with degree 1. With degree 1. Is that understandable to you? So in the examination, if this form is given m dx plus n dy, then what you need to check in the examination hall? You also know that, sir, m is a function of x comma y and n is also a function of x comma y. Like it could be given in this way: 2x square plus y dot dx plus 3y square plus 3xy dot dy equals to 0. This kind of equation could be written. So what you will do, you will make the standard form m dx plus n dy. So after that, what you will do, you will partially differentiate m with respect to y. Okay, what you will do, you will partially differentiate m with respect to y. This m which is connected with dx, no, so that will be partially differentiated with respect to y, and then you will partially differentiate n with respect to x. Is that clear to you? Whichever that is connected with y, that will be partially differentiated with respect to x, and whichever that is connected with x, that will be partially differentiated with respect to y. If both of them are coming equal, then you will call it exact equation, exact differential equation. And if your differential equation is exact, then you can be very happy. Okay, if it is exact, then how will you solve it? So this is how I will solve it. So from here I can write down m dx equals to minus n dy. So when you are solving this particular part, no, what you will do, both of the side you will do, you will do the integration. Here also you will do the integration. So when you are solving this particular part, here what you will do, here you will consider y as constant. You are integrating with respect to x. So consider y as constant. Consider y as constant. And when you are solving this particular part, then what you will do, you will keep the function of x equals to 0. What you will do, function of x should be put as 0. X should not be put at 0. Function of x should be put at 0, or you can say nullify nullify the functions of x, or you can say make n free from x. With the example you will understand everything. Okay, with the example you will understand everything. So sir, how this answer came, sir, how this process came, what is the derivation? That is not useful for you. The derivation is not useful for you. Only thing, m dx plus n dy is written. Partial differentiation of m with respect to y, partial differentiation of n with respect to x. Sir, both are coming equal. That means it is a exact equation. If it is exact equation, then sir, I will be very happy. I simply need to integrate. When I integrate, what I will do, I will make sure one thing. What I will make sure that when I do integration of m dx, when I do the integration of m dx, then I will keep y constant, and when I do n dy, I will make sure that n is free of x. Let's do the examples. It will be more clear to you. So this kind of equation is given in my examination hall. First of all, I will think that if I make dy by dx, from here, if I make dy by dx, then sir, what I will be getting? So dy by dx would be coming out to be 2xy plus 3 divided by 1 minus x square. Can you solve this equation using variable separation? Can you solve it using variable separation? Can you keep x aside, y aside? Is it looking possible for you? Absolutely not. Here only you can say, sir, variable separation will not work. Variable separation, sir, absolutely it will not work. Variable separation, no chance. Then what you will think? Sir, it feels like that it is m dx plus n dy. Where what is your m? Sir, your m is nothing but 2xy plus 3. And what is your n? Sir, n is nothing but x square minus 1. Because you need to take this negative sign inside, no? M dx plus n dy, plus sign is there. You need to take this negative sign inside, plus sign is there, no? So what it will become? Minus of 1 minus x square, or you can say it is x square minus 1. Now you partially differentiate m with respect to y, because m dx is no. So m is connected with dx. So whatever that is connected with x, that will be partially differentiated with respect to y. So partial differentiation of m with respect to y. Partial differentiation of m with respect to y. That answer will be 2x. Now partial differentiation of n with respect to x. Partial differentiation of n with respect to x. What is the answer? 2x only. So sir, if what I can see, that sir, del m by del y is coming out to be equals to del n by del x. That is showing that it is nothing but exact equation. If it is exact equation, then you can directly integrate 2xy plus 3 dot dx minus 1 minus x square dot dy equals to 0. Simple integration we are doing. But here what we will do, whatever the term which is related with x, that will be kept to 0. Let's just say in place of x square, if there was cos x, will I be putting x equals to 0? No. Whatever the term which is related with x, that will be put to 0. Okay. We will nullify that term which is related with x. So complete x square will be going to 0. Here what you will do, you will do the simple integration but keeping y as constant. So first I need to integrate 2xy. So what I will do, sir, 2y will be constant, integration of x will be x square by 2. Then I need to integrate 3, that will be 3x. Did you understand what I did here? Sir, 2y will be treated as constant, 2y as it is. Here it was the scenario, 2xy dot dx plus 3 dx. This will give you 3x. 2y will be treated as constant, x dx. What is the integration of x dx? That will be, sir, x square by 2. So what you are getting? Y x square. So this is what we are getting. And now what will happen? This x square term will be gone to 0. Now what you will get? 1 dot dy. What is the integration of 1 dot dy? That will be y only. Will be equals to 0. This is the answer that you will be getting. Here in place of writing 0, what I will write down? Constant. Because both side integration I am doing, no? So here it will be constant. Here I will be getting constant. So what answer I am getting? Sir, from here answer you are getting is x square y plus 3x minus y equals to constant. This is the answer that we are getting. Is that clear or not? Okay. So this is the answer we have, x square y plus 3x minus y equals to constant. Okay. So let me repeat the process. M is given, n is given, partial differentiation of m with respect to y, partial differentiation of n with respect to x. What you are getting? Both are same, exact equation. Then integrate. This guy you integration, this guy also integration we need to do. When we are integrating here, we will make sure that whatever the term which are related with x, they will go to 0. And when we are integrating this side, what we will make sure that y will be treated as constant. So 2y will be constant here, 3 is already constant. So 2y x square by 2, so y x square plus 3x minus y equals to c. Let's go to the next question. This question that is coming in my examination hall. First of all, I will make the standard form m dx plus n dy. M dx plus n dy. This is the standard form that I am supposed to make. So what I will do, first I will write down this x square minus 4xy minus 2y square dx plus n dy. So this negative sign will go inside. So what you will be getting, minus 4xy minus 2x square plus y square dot dy. Now what you will do, partial differentiation of m with respect to y. Partial differentiation of m with respect to y. So partial differentiation of m with respect to y. So this will be 0, minus 4x minus 4y. Partial differentiation of n with respect to x. Partial differentiation of n with respect to x. What you will be getting when I am doing the partial differentiation with respect to x. So y will be treated as constant here with respect to x. So 4x and this will be 0. Are both of them coming same? Yes sir. What does that mean? That means it is exact equation. If it is the exact equation, then what you will say, sir I am happy and now I will integrate. How will you integrate? X square minus 4xy minus 2y square dot dx plus minus 4xy minus 2x square plus y square dot dy. Now which term you will nullify? Sir, in this term there is x present, no? Nullify. Here also x present, nullified. What is left? Only y square is left. So only this guy would matter. What is the integration of y square? So from here what you will see is that y cube by 3 answer would be coming from this side. Whichever the term which is related with x, that will be nullified. That will be nullified. Only y square is left. So y cube by 3 will be the answer. Here what will be the scenario? Sir, I need to integrate with respect to x. Y will be treated as constant. Y will be treated as constant. So what is the integration of x square? X cube by 3. What is the integration of 4xy? Sir, y will be treated as constant. X square by 2. What is the integration of 2y square? Sir, y will be treated as constant. There you go. This is the answer that you will be getting. Plus y cube by 3, which is coming from here, plus y cube by 3 equals to constant. Surely equals to constant. When you are integrating both of the side, equals to constant. Equals to constant. Is that understandable or not? What I am doing? Again, let me repeat. Whatever the term which are related with x gone to 0, y cube by 3. Here, x cube by 3 minus 4y aside. 4y is a constant. Integration of x will be x square by 2. Here, minus 2y square. Minus 2y square dot dx. This is the integration I am supposed to perform. This is constant. So minus 2y square. What is the integration of dx? That is x only. So minus 2y square x minus 2y square x plus y cube by 3. That's the answer. This is the answer that we are getting. That's it. Okay. So this could be written as better way also we can do. How we can write down? X cube plus y cube by 3. X cube by 3 plus y cube by 3 minus 2 outside you take, minus 2 outside you take, x square y plus x y square equals to constant, right? X cube plus y cube by 3 minus 2 outside you take, because this is becoming 2 x square y plus x y square. So this is the answer that we can write down. Understandable? So this is your exact equation. If there are more questions, yes. So you need to find out the value of k such that the equation is exact. And once you have found out the value of k, no, after that you need to solve the equation as well. Two questions we are supposed to solve. First we need to find out the value of k such that the equation is exact. Now if the equation is exact, then you need to solve the equation. If the equation is exact, then you need to solve this differential equation. Okay. So this is your m, this is your n. Partial differentiation of m with respect to y. What answer you will be getting? Kx plus 2y. Now partial differentiation of n with respect to x. What answer you will be getting? 2x plus ky. Right. So from here what I need to do? Sir, my equals to nx I am supposed to put. That means sir, kx plus 2y would be equals to 2x plus ky. When you solve this equation, the value of k will come out to be 2. So what is the value of k? The value of k is 2. Now if the value of k is 2, you need to solve this equation. So 2xy plus y square dot dx plus x square plus 2xy dy equals to 0. Integrate here, integrate here. Whichever the term which is related with x, put that to 0. Whichever the term which is related with x, put that to 0. So it is completely become 0. What is 0 dot dy? That will be nothing but sir, a constant value. 0 dot dy will be nothing but a constant value, no? Whenever you integrate 0, 0 means 0 Integration of 0 is constant. What is the differentiation of constant? That is 0. So what will be the integration of constant? That would be, what is the integration of 0? That would be constant. That's it. It is very simple. No, what is the integration of 0? That will be constant. So this will be constant, this will also be constant only. So constant will become one constant. Only this part I need to solve. So 2xy, y will be treated as constant, x square y2 plus y square x, right? 2xy. So y will be treated as constant. So 2y aside, integration of x would be x square by 2 plus y square dot dx. So y square x plus constant equals to constant. So c1 c2 I can write down. So what your answer you are getting? X square y plus y square x equals to some constant k. This is the answer that we are getting. Okay. So 2 questions we were supposed to solve. Very easy questions. These kind of questions should be solved in the examination. Very straightforward question. Free marks. Partial differentiation. Sorry, not partial differentiation. They are asking the first order differential equation m dx plus n dy. Partial differentiation of m with respect to y. Partial differentiation of n with respect to x. Both are coming same. Then it is exact. If it is exact, then when you are doing dot dy, keep all the terms of x equals to 0, or you can say nullify all the terms of x, and here you treat y as constant, integrate. Job done. This was your method 2, right? So what all method we have seen? 2 methods we have seen, 2 kind of questions we have seen. First one was variable separation. Variable separation, very straightforward, sir. Clearly it will be visible that variables are getting separated. Here can you apply that method? Which method? Exact equation. X dy minus y dx, x dy minus y dx equals to 0. First write down in this way, minus y dx plus x dy. What is the value of m? The value of m is minus y. What is the value of n? Value of n is x. Partial differentiation of m with respect to y. What is the answer? Minus 1. Partial differentiation of n with respect to x. What is the answer? 1. Are they same? No. That means it is not exact equation. Okay. This equation is not exact. Understandable? So we can make it exact. This equation is not exact. We can make it exact. How we will make it exact? That we will see. So what is the meaning of integrating factor? Two kind of concepts we have seen. First one was variable separation, other one was exact equation. What is the meaning of integrating factor now? So in very simple words, integrating factor means that it will make our question easier. That's it. It will make our differential equation easier. Someone would say that, sir, I know how to solve this equation. Y dx minus x dy. Sir, it is always easy for me. Y dx could be written as x dy. Then, sir, x goes aside, 1 by x dx. Then y goes downside. Sir, I can easily solve it. But it is not an exact equation, no. If someone doesn't know the variable separation method, let's just say someone does not know the variable separation method, I only taught him this method only. That if the equation is exact, then this is how you can solve. Now, if this question is coming, y dx minus x dy, what he will do? He will check whether my equation is exact or not. Y dx minus x dy equals to 0. So value of m is y, value of n is minus x. Partial differentiation of m with respect to y will be 1. Partial differentiation of n with respect to x will be minus 1. What you can see here? Both are not same. That means it is non-exact equation, non-exact differential equation. Now what he will do? I am stuck. I cannot solve the equation. Then he will go to integrating factor. What integrating factor would say? That if you multiply me with your equation, no? If you multiply me with your equation on left hand side as well and right hand side as well, then I will make your equation easier. 1 by x square is saying that if you multiply me, no? If you multiply 1 by x square with this differential equation, then I will make your equation easier. How will you make your equation easier? Let's see that. First one is, if I treat my integrating factor as 1 by x square. So what this guy is saying? This guy is saying that your equation is y dx minus x dy, no? Y dx minus x dy, which is non-exact, equals to 0, which is non-exact. If you multiply me, no, then I will become exact. If you multiply me, no, 1 by x square. On both of the side, I am multiplying with x square. So what I will be getting? Y by x square dot dx minus x divided by x square, that will be 1 by x dy. So he is saying that now I will become exact. So let's check whether it is exact or not. Let's check whether now the equation is exact or not. What is the value of m? The value of m is y by x square. And what is the value of n? The value of n is 1 by x. Okay, minus 1 by x, sorry guys. So what will be the partial differentiation of m with respect to y? With respect to y you are supposed to solve. So 1 by x square will be treated as constant. Differentiation of y will be 1. Partial differentiation of n with respect to x. What is the partial differentiation of 1 by x? So that will be 1 by x square minus 1 by x square, minus minus will become plus. Are they both becoming same? Absolutely yes. Del m by del y is coming out to be del n by del x. What does that mean? That it has become exact. So just by multiplying 1 by x square, can I multiply with 1 by x square on both of the sides? Yes sir. If 2 is 2, 2 equals to 2, then can I multiply 3 on both of the sides? Absolutely. So if y dx minus x dy equals to 0, can I multiply with 1 by x square on both of the sides? Absolutely. 0 multiplied with 1 by x square will be 0 only. So now it has become exact. Can I solve the exact equation? Can I solve this equation? Can I solve this equation now? Absolutely. Y by x square dot dx minus integration 1 by x dot dy. What did I say? The terms related will be equals to constant. The terms related to x will be thrown to 0. I will not put x equals to 0. No. The terms which are related with x or the function of x will be thrown to 0. So what this will become? Let's call it c1. What this will become? This will become 0 dot dy. This will become 0 dot dy. What is the value? Another constant. And here y will be treated as constant. What is the integration of 1 by x square? What is the integration of 1 by x square dot dx? What is the integration? That is x to the power minus 2 dot dx. That would be x to the power minus 1, that is minus 1 by x. So here what you will be getting? Y you take aside, minus y by x. This will come out to be minus c2 equals to c1. So eventually what is the answer you are getting? Some constant equals to constant. So y by x equals to some constant you are getting. That means y equals to kx you are getting. Someone would say, sir, where this negative sign go? Negative sign has been thrown into constant. No. Like what I am getting, minus y by x minus c2 equals to c1. So from here minus y by x equals to c1 plus c2. What is this? This is a constant. The negative sign you take aside, y by x minus c1 minus c2. What is this? This is another constant. So y by x equals to some constant k, y equals to kx. Okay, so this is what we are getting. So from here what you are getting, y equals to kx. Again the same answer, whatever that you expected, the same answer you are getting, y equals to kx. Here also I expected the same answer. No, y dx minus x dy. How would you solve it? Y dx minus x dy. Y dx minus x dy. How would you solve it? Sir, variable separation. It would be written as y dx equals to x dy. This x coming aside. So 1 by x dx equals to 1 by y dy. So this will become ln x equals to ln y plus c. So ln x minus ln y. So that would be ln x by y would be equals to c. So x by y would be equals to e to the power c. That would be constant. So x equals to ky you can say, or y equals to kx also you can say, because this comes this side, then what it will become? If this k becomes this side, then it will be another constant, no? So y equals to mx also you can say. So yes, same answer we are getting. Y equals to mx or y equals to kx, same answer we are getting. Understandable? So what is the job this 1 by x square is doing? 1 by x square is saying that I am making your equation easier. Yes, you are making my equation easier. That means yes, you are my integrating factor. Now let's observe a very interesting and very important thing. Okay, very important thing we are going to discuss now. Keep your full focus here. Otherwise, you will not be able to solve the questions. What I am asking you? I am asking you very simple thing. That is, you find the integration with respect to t. Which function integration you need to do? You need to do the integration of y by x. You need to do the integration. Sorry, not integration. Sorry, guys. You need to differentiate y by x with respect to t. What you need to do? You need to differentiate y by x. You need to differentiate y by x with respect to t. Can you differentiate it? Yes, sir, absolutely. It is u by v, right? U by v. So in the denominator, x square, then x goes here, then differentiation of y with respect to t minus then y as it is, differentiation of x with respect to t. So what is the answer you are getting? Sir, x dy minus y dx divided by dt dot x square. So dt and dt get cancelled out. So what you are getting? D y by x is coming out to be divided by x square. Directly you try getting answer from here. Dy by x. That means you are differentiating y by x. So x square, then x as it is, differentiation of y, minus y as it is, differentiation of x. This is the answer that you are getting. So d of y by x could be written as x dy minus y dx divided by x square. As of now, you don't need to remember it, but later on I will tell you what you need to remember. Later on I will tell you what you need to remember. As of now, you don't need to remember it, but later on I will surely tell you something to remember. Do you remember this thing? D of xy? Yes sir. X dy plus y dx. Say yes or no. Do you remember it clearly? Absolutely sir. Okay. So yes, we will see something what we need to remember, but as of now you can see there is interesting result. D of y by x could be written as x dy minus y dx divided by x square. Say yes or no. Similarly, there is part B. What is my integrating factor in part B? Integrating factor in part B is 1 by y square. In this question there are 4 parts, no, A, B, C, D. If one of like which of them are integrating factor, this is what they are asking. It is a MSQ. Which of them are integrating factor, this is what they are asking. So what I need to check, if 1 by y square is my integrating factor or not. What is the use of 1 by y square? That you multiply me both of the sides, I will make your equation easier. So let's see if you are doing this work or not. Y dx minus x dy. Y dx minus x dy. Multiply with 1 by y square on both of the side. Are you making my equation easier or not? So what you are getting? 1 by y dx minus x by y square dy equals to 0. So from here, what is the value of m? 1 by y. What is the value of n? Minus x by y square. So partial differentiation of m with respect to y is minus 1 by y square. Partial differentiation of n with respect to x is also minus 1 by y square. Are both of them same? Yes sir. Partial differentiation of m with respect to y, partial differentiation of n with respect to x. Yes, both are same. That means yes, now it is becoming exact equation. And if it is becoming exact equation, can you solve it directly? Absolutely sir. How will I solve it? Both of the side I need to integrate x by y square dy. Do I care about this particular thing now? No. Whatever, if there is a function related to x, keep that equals to 0. So this whole function is gone. So what that would be equivalent to? This will come out to be some constant. This is already some constant here. Constant. And what is the integration? 1 by y I will give aside. What you are getting? X by y equals to some constant k. So from here what you are getting? Y equals to mx again. Again the same answer you are getting. Right? What does that mean? That means yes, 1 by y square is also helping. That means this guy was also helpful. So this guy was also helpful. Now let's see another interesting thing. Y dx minus x dy divided by y square. What do you think what it is equivalent to? What do you think what it is equivalent to? Can I write it down equivalent to d of x by y? Say yes or no. What will be your d of x by y? So that would be nothing but denominator y square as it is, then y differentiation of x minus x differentiation of y. This is how you can write down d of x by y. D of x by y we have got. D of y by x we have already got. What was d of y by x? That was nothing but in the denominator there was x square x dot dy minus y dot dx. This was your d of y by x. What was your x dy plus y dx? X dy plus, let's not write it down again. Here only we know the answer. X dy plus y dx. Okay, let's go to the third guy. Now they are saying that my integrating factor would be 1 by xy. Now another new guy is coming. He is saying that 1 by xy will also make your equation easier. Let's check if they are making my equation easier or not. Y dx minus x dy equals to 0. Y dx minus x dy equals to 0. I need to multiply with 1 by xy. I need to multiply with 1 by xy. So what I will get? Like what you are doing is that y dx multiply with 1 by xy, so divided by xy, minus x dy multiply with 1 by xy, so divided by xy. So what you are getting? 1 by x dx minus 1 by y dy. Is it making my equation easier? Is it exact equation? I don't know whether it is exact or not, although it is exact equation only. What is the value of m? Value of m is nothing but 1 by x. What is the value of n? The value of n is nothing but minus 1 by y. So partial differentiation of m with respect to y, that would be 0 because there is no term of y. And partial differentiation of n with respect to x, that will also be 0 because there is no term of x. So yes, it is exact only, both are same. Yes, it is coming out to be exact equation. Or simply you integrate, no, on both of the side you integrate 1 by x dx. 1 by y dy. What will exact equation will say? That here whatever the term which is related with x, that you put to 0. There is no term which is related with x. Here you treat y as constant. There is no term of y. So what is the answer you are getting? From here, the answer that we are getting is ln x minus ln y equals to constant. So ln x by y equals to constant. So y equals to, this will become e to the power c. So y equals to again mx. Y equals to mx. Again the same answer. Yes, so this guy is also making my equation easier. This guy also is making my job easier, right? So this guy is also pretty good. Now, what another thing I can think? I will have to add a lot of pages. At least 3 more. Okay, 3 more, not even allowing. What I will have to think? Can you think of the answer of d by dt? You need to integrate, you need to differentiate with respect to t. Which function you need to differentiate? You need to differentiate ln x by y. This is what you are supposed to differentiate. Can you differentiate it or not? Like, what is that differentiation of d by dt of f of x comma y? So first you will differentiate function x. Sorry, first you will differentiate function f. Function f. Or let's just simply write down one thing. Let's keep it as a function of x only. So what will be the answer? First I will differentiate the function x function, and then I will differentiate x. Say yes or no. So first you differentiate your function. What is the differentiation of ln x by y? That is nothing but, sir, 1 upon x by y. Then you differentiate x by y. How will you differentiate x by y? Sir, for differentiating x by y, what I will do? It is u by v. So y square y dx minus x dy. Say yes or no. I hope you are able to understand what I have done here. First you differentiate this function, which is a ln function, which will be 1 by x by y. Then I will differentiate x by y. That will be y square dx by dt. You are differentiating with respect to t, no? Dy by dt. But eventually you know that, sir, dt will get cancelled out. So let's remove dt now. Because dt will come in the denominator, that will get cancelled out. Let's remove dt now. Let's remove dt now. Now you can see that, sir, this y and this y is getting cancelled out. So what you are getting eventually you are getting d of ln x by y is coming out to be what? Y dx minus x dy divided by xy. This is what we are getting. Say yes or no. Similarly, if I ask you, what will be your d of tan inverse y by x or tan inverse x by y? Tan inverse x by y. What will be your answer? First I will differentiate this function. What is the differentiation of tan inverse x? What is the differentiation of tan inverse x? So that is nothing but 1 upon 1 plus x square. So the answer will be 1 upon 1 plus x square by y square. Then what is the differentiation of x by y? So that would be nothing but y square y dx minus x dy. Now this y square goes this side, this y square goes this side, and y square will get cancelled out. What answer you are getting? Y dx minus x dy, or let's write down in a better manner. So d of tan inverse x by y is coming out to be y dx minus x dy divided by x square plus y square divided by x square plus y square. Look, the motive of this question was not to solve this question. Actually, my motive was to let you know the meaning of integrating factor. This will also come out to be an integrating factor. This you can check on your own. Surely this will also come out to be an integrating factor. You can check on your own. Okay. There was something else. The motive was something else. The motive was to treat you some method. What is that method? That we will see. But let's check this option now. Let's check this option. Sorry. Let's check the option D now. What I need to do? I need to multiply with 1 by x square plus y square on both of the side. That means y dx minus x dy equals to 0. On both of the side I will multiply with 1 by x square plus y square. So what I will be getting here, x square plus y square divided by x square plus y square. So this is something that I will be getting. Now what is this thing? What is this thing? So this particular thing could be written as d of tan inverse x by y. Say yes or no? This is how it could be written. So d of tan inverse x by y, what that would be equivalent to? This particular thing could be written as d of tan inverse x by y. Where I have shown it? Here I have shown it. D of tan inverse x by y. This is something that we are getting, x square plus y square y dx minus x dy. So that would be equivalent to 0. Now both of the side you take integration. What answer you are getting? So tan inverse x by y equals to some constant. Now this tan goes here. What you are getting? X by y equals to tan c. So tan of some constant will be a constant only. So x by y equals to some constant k, y equals to mx. Again the same answer we are getting. Right? So this was just a proof that yes, this guy is also making my equation easier. 1 upon x square plus y square is also making my equation easier only. This was the proof. Sir, why you taught all these things? What is the meaning of this particular thing? What is the meaning of this particular thing? What is the meaning of this particular thing here? So let's write down everything. Whenever you see y dx minus x dy, or you see x dy minus y dx, whenever you see these two guys, who is important here? Minus sign is important. Who is important? This minus sign is important. This guy is important. Whenever you see the negative sign, because you know that, sir, if I see the positive sign, no, x dy plus y dx, let's just say, sir, I see this thing, then I know that, sir, it could be written as d of xy. But sir, when I see y dx minus x dy, do I know anything? This thing, sir, I already know. I don't have any problem with that. But do I know anything for this? I told you he is having no brother. He doesn't know anything. Y dx minus x dy could not be written by anything. But you will remember one thing. You will remember that, sir, they are the brothers of x by y or y by x. Because you know that, sir, if I calculate d of x by y, no, then what I will get? Y square, y dx, then x dy. Say yes or no? Sir, if I write down d of y by x, what I will get? Numerator, this is denominator, x square, x, then differentiation of y will be dy minus x differentiation of, minus y as it is, differentiation of x dx. So, sir, x dy minus y dx I need, no, then x by y or y by x can help me. Now, sir, I have some tools that I know that, sir, d of x by y could be written as, y square downward y dx minus x dy. Sir, another thing I know. What do I know? D of y by x is written as x square x dy minus y dx. Another thing, sir, I know, d of, next what we show? Next we show d of ln. Look, if y dx minus x dy is there, no, so surely it would be either x by y or y by x. So what I can think? I can think of ln. So, sir, it could be written as ln of x by y. Ln of x by y. So how will you solve it? So first, sir, I need to differentiate this guy. What will be the answer? 1 upon x by y, and then I need to differentiate inside. So what I will be getting? Y square y dx minus x dy. So this and this get cancelled out. So y dx minus x dy divided by xy. Y dx minus x dy divided by xy. Y dx minus x dy divided by xy. Another thing, sir, I know, d of ln y by x. Now if I know the answer of this guy, do I need to solve this one? No, only that there will be a difference of negative sign. So x dy minus y dx, you can solve it on your own. This is the answer that you will be getting, divided by xy. So, sir, I will think of x by y, y by x, then I will think of direct x by y, y by x, or I will think of ln, or I can think of tan. Okay, or what I can think? I can think of tan inverse. Tan inverse, in the bracket what I will write down? Sir, there is a negative sign, no? So either x by y or y by x. So when I write down x by y, what answer I will be getting? Y dx, you can solve it on your own. We have already solved it. Y dx minus x dy upon x square plus y square. Upon x square plus y square. Upon x square plus y square. And then another one, d of tan inverse y by x, that would be x square plus y square x dy minus y dx. So do I need to remember all these things, whatever that has been written on this slide? No. There should be something that should click in your mind whenever you see the negative sign. Whenever you see the positive sign, you will be very happy, sir, it is very straightforward, d of xy. But when I see the negative sign, sir, it is having no brother. They are having cousins. He is the brother, they are brother, but they are having cousins. That some help I will need. I will need the help of 1 by y square, 1 by x square, xy, x square plus y square. So whenever you see the negative sign, x dy minus y dx, whenever I see the negative sign, or if I see y dx minus x dy, just this negative sign whenever I see, sir, something will start clicking to me. What will start clicking to me? Sir, d of x by y or y by x, or sir, d of ln, since there is a negative sign, so always here y by x or x by y, or sir, d of tan inverse y by x or x by y. Along with that, what else thing I will, what else should click? That, sir, when I solve this guy, no, so in the denominator either I will get y square or I will get x square. That means when I solve them, either I will get y square or I will get x square. In the denominator, sir, I will get xy as well. Sometimes I can get xy as well, or sir, sometimes I can get x square plus y square as well. So these are the things. If these are the things that are clicking to you, no, then surely you will be able to solve the question, which is based on inspection method. This is a new method that we are going to learn, which is known as inspection method. Okay. So if this much is clicking to you, then your job would be done. Just as you look at the negative sign, something should click in my mind. First thing that will click is that is y by x. Surely it will be a function of y by x. Now, sir, in the denominator there could be y square, x square, or xy, or x square plus y square. If something like that is given, no, then sir, something I can do, something good I can do in my life. I can make d of y by x, d of ln y by x, or d of tan inverse y by x. We will solve the question, it will be clear to you. But whatever that I have told in this slide, I hope it is completely clear to everyone. This is known as inspection method. It is given in the IIT Kharagpur NPTEL playlist. Okay, you can check that playlist. And I am pretty sure in the future, if the question is coming, no, it will come on this topic, which is not taught by a lot of, which is not studied by a lot of students. Okay, it is given in IIT KGP NPTEL playlist, which is new only 2-3 years back only they have framed it. So we will solve the questions, some 4 to 5 questions we will solve, and it will start clicking to you. But negative sign, just as you see negative sign, no, then also you should be happy. When you see positive sign, you will be very happy. So job is done. Whenever you see negative sign as well, no, then also you will be happy. Why you will be happy? Because sir, something I can do. I can think of, sir, x by y or y by x, or sir, in the denominator there could be x square or y square, sir, or x square plus y square or xy. Then sir, something I can do. Ln tan inverse d of y by x, d of x by y, d of ln y by x, or d of ln x by y, d of tan inverse x by y, d of tan inverse y by x. Something I will be able to do. We will solve the questions. It will be clear to you. Let's see this question. Integrating factor you need to tell. Very straightforward. X dy plus y dx. X dy plus y dx. X dy plus y dx equals to 0. Sir, it could be itself, it could be written as d of xy equals to 0. Both of the side I will integrate. What answer I will be getting? Xy equals to constant. If I multiply with 1 on both of the side, am I making my equation easier? Yes. If you multiply 1 on both of the side, you are making your equation easier. It is always easier only. It is already easy. So yes, you are making your equation easier. Next, x dy plus y dx, you are multiplying with 1 by xy on both of the side equals to 0 by xy, so 0. Now what you need to do? Sir, x dy plus y dx could be written as d of xy divided by xy equals to 0. So can I treat d of xy is there, no? So can I treat this as theta divided by theta? So what will be the answer? Ln theta equals to 0. Are you able to understand this point? What I am doing here? I am treating xy as theta. So d theta by theta equals to 0. So ln theta equals to 0. What you need to do? What you need to do? D theta by theta. How you got it? Ln theta equals to constant. Sorry guys. What I have done is that on both of the side I have integrated. On both of the side I have integrated. No. Are you able to understand this point? dxy divided by xy. If dt by t is written, if you integrate, what answer you write down? Ln t. If d theta by theta is written, if you integrate, what answer you will write down? Ln theta. If dx by x is written, what answer you will write down? Ln x. So if d xy divided by xy is written, then what answer you will write down? Ln xy. That's it. Right? So similar thing. Needlessly I am making it complex. So what I did was I just put xy as theta. Xy as theta. What I needed to do here, what I did was I put xy as theta. So from here what I am getting? D theta by theta. So ln theta equals to constant. So from here what I am getting? Theta equals to e to the power constant. So theta equals to k. And what is theta? Theta is nothing but xy. So xy equals to k. This is what I am getting. Yes, I am able to solve the question. But the important part is that whenever you see this particular thing written, what I mean to say is that whenever you see d of xy divided by xy, and then I integrate on both of the sides, then directly will your hand work in this manner? From here to here, will you be able to write down directly? This is something that I am asking. D of xy, lag gayi yaar yahan se. So d of xy divided by xy. So it is like d of t divided by t. So can you write down ln t directly? Absolutely. So d of xy divided by xy, d of t divided by t, ln t. Are you able to understand this point? So directly it should click to me. Is that clear or not? Absolutely clear. Okay. So this is also making the equation easier. Next one, 1 by x square plus y square. This is not a gate question, no? Are you able to understand this point? This question will not be asked in the gate examination. That what is the integrating factor? Here I am just telling you what is the meaning of integrating factor. Along with that, I am teaching you this technique, because our next method is inspection method. We will solve the question with the inspection. There we will think. There is no method there. Use your brain. And how you will use your brain? This is how you will use your brain. So I am telling you how to use the brain, nothing else. Okay. So this is not a gate question that this will be asked in the gate examination. No. This is just a concept learning question. So x dy plus y dx. If I need to divide with xy whole square, then what I will get? So upper side I can directly write down d of xy divided by xy whole square. Now both of the side you integrate and let me know what is the answer you will be getting. Both of the side you integrate and let me know what answer you will be getting. You should be able to write down on your own. If I write down dt by t square, what answer I will get? Minus 1 by t. If I integrate, what is the integration of 1 by t square? What I am asking, what is the integration of 1 by t square? What is the integration of 1 by t square? Sir, integration of 1 by t square is nothing but minus 1 by t, or can I write it down in this way? Dt by t square. So similarly it is dt by t square. So it can come out to be minus 1 by xy will be equals to constant. So from here what you are getting? Xy equals to some constant value k. That's it. Again the same answer you are getting. But it should click to you. D of xy divided by xy whole square. What it could be written as? Minus 1 by xy. Because d of t divided by t square. D of t divided by t square could be written as minus 1 by t. So similarly, d of xy divided by xy whole square could be written as minus 1 by x. Minus 1 by xy. That is equals to c. Okay. Next. Which is, so this is also making the equation easier. 1 upon x square plus y square. X dy plus y dx upon x square plus y square equals to 0. So upper side could be written as d of xy divided with x square plus y square equals to 0. On both of the side you integrate. On both of the side you integrate. You are stuck now. Right? You are stuck now. What you will do? Sir, here d of xy divided by xy whole square. Sir, d of xy divided by xy. Sir, here directly xy equals to c. What I will do here now? I am stuck. Right? D of xy divided by x square plus y square. You are stuck now. You cannot proceed. So it is not making your equation easier. Previously I was already, it was easy only. Now dividing or multiplying with 1 upon x square plus y square, it is making it difficult. No, it is not making it easier. This does not make any sense, right? It is not making my work easier. So this is not an integrating factor. You are stuck here. You are stuck here. Say yes or no. Are you able to understand this point or not? Are you guys understanding or not? I know it is not very straightforward, but using the brain, here brain is used. Understandable? Now let's think of something else. Let's just say if I ask you how this could be written, x dx plus y dy. Like basically what we have understood that sir, x dy plus y dx, sir, I use my brain, it could be written as d of xy, right? Sir, I use my brain, this is how it could be written. I am asking you how you can write down x dx plus y dy. Use your brain and let me know how it could be written. Sir, it could be written as d of x square plus y square. What this will give you? D of x square plus y square. So d of x square plus y square will give me d of x square plus y square. So it could be written as d of x square plus d of y square. So what is the meaning of d of x square? That will be 2x dx. What is the meaning of d of y square? That will be 2y dy. But I need x dx plus y dy. That means I need to divide by with 2. That means here I need to divide with 2. Or I can say it could be written as 1 by 2 d of x square plus y square. What is the meaning of d of x square? That means you need to differentiate the function x square, that is 2x dx. You need to differentiate the function y square, that is 2y dy. This 2 I don't need. This 2 I don't need. That means I need to divide with 2. So x dx plus y dy could be written as 1 by 2 x square plus y square. 1 by 2 x square plus y square. Say yes or no. Okay. Now you answer me this thing. What this could be written as? Can you think of something? 2 e to the power y x dx plus x square e to the power y dy. What this could be equivalent to? Does it click to you? I know it is not very straightforward to that, sir. I will see the question and it will click to me in the examination hall. I am telling you it is not very straightforward. But still, if it is clicking or not. In the examination, I am telling you 99% problem will be solved till here. That's it. If your concepts are till here, no, then you will be able to solve the questions. This is just a practice that if it is clicking to you or not, that it could be written as d of x square e to the power y. Sir, x square as it is, differentiation of e to the power y will be e to the power y dy. Sir, e to the power y as it is, differentiation of x square will be 2x dx. So 2 e to the power y x dx plus x square e to the power y dy. Say yes or no. Right? So I can say yes, it is not very straightforward, but if it clicks to you, then it is good, right? But these kind of questions will not be asked in the examination. These knowledge will be helpful. This knowledge will be helpful, and whatever that we have described on this slide, that will be surely helpful. If it is written in this way. So what do you think? It is nothing but d of x square by e to the power 2y. Sorry, x square by e to the power y. Right? Because how will you do? Square of this, then e to the power y, then differentiation of this, that would be 2x dx minus x square as it is, differentiation of e to the power y will be e to the power y dy. So yeah, sir, it is nearly impossible to click in the examination hall. That, sir, I will see this expression and I will be able to write down d of x square by e to the power y. It is nearly impossible. But who knows the same expression is coming? Who knows the same expression comes? Right? So if it is clicking, then it is good. Or you can think like here square is given e to the power y, then x square would be 2x, here x square as it is. Something like thinking. Only it is based on inspection, nothing else. Next question, sir. Everything will be based on inspection. If this question is coming in front of your screen in the examination hall, what you will do? Sir, first of all, I will think of variable separation. Is it possible here? It feels possible. Here, first of all, what I will do, I will think of a variable separation. What I will think that, sir, this particular equation I can write down in this way, that it is y square plus 1 dot dx would be equals to minus x y square minus 1 dot dy. So what I will do is that these guys aside, minus 1 by x dx equals to y square minus 1 upon y into y square plus 1 dot dy, and then both of the side integration. So if you know this integration, you can do it. Plus minus 1 I can do, no? Plus 1 minus 2, then do. Although you can proceed here, but it will be lengthy. Yes, you can proceed. Variable separation, yes, it is working. First one was variable separation, it is working, but again it will be lengthy. It will be lengthy. Second, they are surely not exact equation. They are not exact. You can check, they are not exact. You can check. On your own, you can check that, sir, partial differentiation of m with respect to y, partial differentiation of this with respect to y will not come out to be partial differentiation of n with respect to x. You can check it on your own. They are not exact for sure. So what then next, what will click to me? The next that will click to me will be my inspection method. So let's try looking at something. Sir, it is y cube plus y dx, or I can write down y cube dx plus y dx plus xy square dy minus x dy equals to 0. Sir, something y dx minus x dy. Sir, these guys can do something. These guys can create some magic. Plus xy square dy plus y cube dx equals to 0. Now, sir, I know that alone this guy cannot do anything. Here also, sir, there are some problems, right? Now I know that, sir, if I remove this y square and if I make this as only y, then what I will get? X dy plus y dx. So, sir, clearly I also know that, sir, y dx minus x dy also alone cannot do anything. So, sir, clearly it is giving me a notation, or it is giving me an indication that let's divide with y square. Let's divide with y square. Let's divide with y square. Whole equation has been divided with y square. So if I divide the whole equation with y square, what I am getting? What is this? Sir, it is nothing but d of x by y. What will be your d of x by y? So that will be nothing but y square y dx minus x dy. So it will be d of x by y plus, here what will happen? This y square will get cancelled out. So x dy, and what will happen? Y dx. Now what is x dy plus y dx? Sir, that is nothing but d of xy. This is equals to 0. So from here, d of x by y plus d of xy equals to 0. So d of x by y equals to minus d of xy. Both sides you integrate. What answer you will be getting? X by y would be equals to minus xy plus constant. There you go. This is the answer. From here also you will get the answer, but do you really think that it is very straightforward? It will take a lot of time. You can do the partial fraction here. Here you can do the partial fraction. If it is clicking to you very directly or not, will it click to me? Y square minus 1 upon y cube plus y, if I do the partial fraction, it will be difficult to solve. Okay, difficult. This particular process is difficult. You can surely do, but it is difficult. But here, sir, if I just think a bit, sir, what is the method? Sir, I am not 100% confident. Sir, will I be able to think in the examination hall? All the question would be there. Sir, will I be able to think? I am not 100% confident. So these kind of topics are there where you can never be 100% confidence. Where you can never get 100% confidence. You see it. If you are able to think, then you are able to think. If you are not able to think, then you will be dropping this question. That's it. So if you just use your pen, then yes, it might happen that you will be able to solve. If you don't use your pen, then you will be struggling. For this question, there will be another method as well that I will tell you later on. Okay, but this is the best possible method, which is inspection. By looking at the equation, this is how you can think. Y dx minus x dy, then sir, divided by y square, it will give me something. And this you would have understood, no, that this integration and d is cancelling out each other, integration d cancelling out each other. Okay. Next question. Sir, already this guy. Sir, already this guy always makes me happy. And do I have the problem with this guy? Absolutely not. With dx, the terms of x are present. Like if someone would ask me, are you happy doing this integration? You will say, sir, I am very happy, because with the x, function of x are present. So I will be very happy, x plus x cube by 3. That's the answer, x plus x cube by 3. So I will be very happy doing this integration. So I already don't have any problem with this guy. But here, sir, I know that alone this guy cannot make anything. Alone this guy cannot make anything. He needs someone. Whom he needs? He needs someone to get divided with. Will I divide with xy? If I divide with xy, what will happen? Sir, here already it is 1 plus x square dot dx. If I divide with xy, sir, needlessly, sir, previously I was happy, needlessly you have introduced y, sir. Why you are introducing y? Sir, previously already I was happy. So, sir, divided by xy, I will not do. Will I divide with x square plus y square? X square plus y square. Sir, again needlessly y is coming. Look, whenever you see y dx minus x dy, whom you will think of? Sir, there are 4 guys whom I will think of. Sir, either I will divide with 1 by x square, or I will divide with y square, or I will divide with xy, or I will divide with x square plus y square. I will either divide with x square, or I will divide with y square, or I will divide with xy, or I will divide with x square plus y square. So, sir, if I divide with xy, there is problem. If I divide with x square plus y square, you are needlessly introducing y square here. If you divide with y square, then sir, again you are introducing y. If I divide with x square, then you will be happy. That, sir, you divide with x square, I don't have any problem. Here you divide with x square, here also you divide with x square. X square equals to 0. What this is coming out to be? What is the value of d of y by x? So d of y by x would be nothing but x square x dy minus y dx. So it is coming out to be minus sign, because it is y dx minus x dy, no? So if I put what is the value of minus of d of y by x? So that would be nothing but y dx minus x dy upon y square upon x square, sorry, upon x square. So minus d of y by x plus, what is this? 1 by x square plus 1 dot dx equals to 0. So let's keep this as it is, minus d of y by x plus, what we are doing now? We are just simply integrating now. We are simply integrating on both of the sides. This integration we are doing. So what you are getting here, you will get minus 1 by x minus y by x. So this will get cancelled out. Here what you will get? What is the integration of 1 by x square? That is nothing but minus 1 by x. And what is the integration of dx? That is x equals to constant. What is the integration of 1 by x square? What is the integration of 1 by x square dot dx? That is nothing but minus 1 by x. Right? Minus 1 by x. What is the integration of 1? Integration of 1 is x plus c. This is the answer that you are getting. That's it. So minus y plus 1 plus x equals to c. This is the answer that we have. Or you can write down x square minus y minus 1 equals to cx. This is the answer that we have. This is just a adjustment. I am just adjusting it here. Okay. Okay, so yeah, that's it. This is the solution. Again, inspection. That will I divide with y square or xy or x square plus y square, that you need to think. Here also division was important, but here you can clearly know that, sir, this y square and y square I need to cancel out, so I will have to divide with y square. So here also we got the answer. Understandable? Is that clear now? Okay. This is 1. This is nothing but 1. Think about this. X square plus y square dx plus 2x dy minus y dx, or x dy minus y dx, x dy minus y dx. Clearly I can see that, sir, this x square plus y square is creating the problem. What I do, I divide with x square plus y square on both of the side. So this x square plus y square divided on both of the side plus 2 x dy minus y dx divided with x square plus y square equals to 0. Now x dy minus y dx divided with x square plus y square. So tan I need to think of. Tan inverse, let's think of x by y. Randomly I am thinking of tan inverse x by y. What is the answer I will get? What is the answer that I will be getting? So the answer that I will be getting is 1 upon x square plus y square. 1 upon 1 plus x square plus y square multiply with y square here, y dx minus x dy. So what you are getting? Y dx minus x dy, y dx minus x dy divided with x square plus y square, x square plus y square. But sir, here there is negative sign, no? Here there is negative sign. It is x dy minus y dx. That means you need to multiply with another negative sign. You need to multiply with another negative sign. You need to multiply with another negative sign. X dy minus y dx. X dy minus y dx. So what you are getting? Here you are having dx only. This 2 as it is, and this could be written as d inverse x by y. This is what you can write, equals to 0. Is that clear or not? X dy minus y dx upon x square plus y square could be written as minus of d tan inverse x by y. Minus of d tan inverse x by y, and 2 aside. Both of the side, what you will do? Integration. This 2 is constant only, no? So x minus 2 tan inverse x by y equals to constant. That's it. This is the answer. Now some guy would be thinking that, sir, I got different answer. What he would have got? He would have got a different answer in this way, because he would have thought here, what he would have thought? He would have directly thought of something else. He would have thought of d of tan inverse y by x. So then he would have got x square plus y square, then x dy minus y dx. This is what he would have got. So sir, directly here, if I say answer 2, not method 2, answer 2 I am talking about. I am talking about answer 2, not method 2, answer 2 I am talking about. So what is the scenario? Dx plus 2 aside, x dy minus y dx. So this is coming out to be 2d of tan inverse y by x, equals to 0. On both of the side you integrate, so this will come out to be x plus 2 tan inverse y by x equals to here constant. Both answers are same only. This answer and this answer both are same only. How they are same, I am leaving it up to you. How they are same, I am leaving it up to you. I will only tell you one thing. What is that? Sir, I know one relation which is tan inverse minus x is equals to pi by 2 minus tan inverse x. This is the relation that I know. No. Tan inverse 1 by x. Yes. Tan inverse 1 by x equals to pi by 2 minus tan inverse x. Using this relation, you do something. I don't know what you will do. Using this relation, you will prove that both of them are same. It is very easy thing. If you are not able to prove this thing that both of them are same, then there is a problem. Let's call this as constant C1, this as constant C2. Constant would be different, but both of the expression are same only. Both of the answers are correct. This answer is also correct. This answer is also correct. Why they are correct? Why they are same? That is up to you now. I am leaving it up to you. Is that clear or not? Use this relation, no? Tan inverse 1 by x. So it is clearly visible. Tan inverse y by x would be equals to pi by 2 minus tan inverse x by y. So from there you will get the answer. Okay. So it was simple only. Let's solve this question. You try doing it on your own. I will take a break and then I will come back. Solve this one on your own. Okay. Think about it. Try doing it on your own, and then after a break I will come back. Yeah, welcome back. Did you try this question? Yeah, actually there is a problem when I close the video, no? When I stop the video and I close the slide. So few of the previous slides did not get saved. Okay. Few of the previous slides did not get saved. Although I have rewritten them, but exactly not that I have taught. Everything has been taught in the video, but I had to rewrite the slides because these some 10-12 pages they did not get saved. Like before this, yeah, everything is saved, but starting from this particular portion, the file did not get saved. Okay, this file did not get saved. So what I did was I again rewrote it, but in a brief manner I have written it. So in the notes you will find something different. Your notes would be a bit different than what I taught. because whatever that I taught, that did not get saved. Video is there, but not in the slides. Okay, so I hope you guys will be fine with that. It's just that everything I have already written. If you feel like that I want to add up something, then what I do is that I will I'm giving you a free page. Let's just say I will give you a free page. Before this, I am giving you a free page. If you want to add up something on your own, you can add it up. Okay, so let me give you a free page here. So in this free page, you can write down anything that you want to write down. Here in brief, I have written the solutions. In brief, I have written the solutions. If you want to write down something else, then enough space I am giving you, more than enough space I am giving you. You can write down here. Okay. So yeah, that's the thing, that files did not get saved actually. But yeah, this is not a big matter of concern. Only 10-12 pages are there, which is fine for you. So did you solve this question? Were you able to solve it or not? Sir, x dx minus, if I see the numerator, it is sir x dx minus y dx plus x dy plus y dy divided by x square plus y square divided by x square plus y square. And here also sir, x dy plus y dx divided by xy whole square. Right? Now you see one thing. X dy minus y dx. Can I write down x dy minus y dx? Because I know that sir, this is a standard pattern. Divided by x square plus y square. Sir, this is completely standard pattern, sir. This is a complete standard pattern. Plus, sir, x dx plus y dy. Sir, this is also standard, no? X dx plus y dy. Did we talk about it? Absolutely. Divided by x square plus y square. Divided by x square plus y square. And then, sir, here what it is? X dy plus y dx. Sir, this I already know, it is d of xy divided by xy whole square. So this also we have already talked. What this is? So this is nothing but d of tan inverse y by x. You can check it. This is d of tan inverse y by x. Sir, what this is? Can you think of it? Can you think of x dx plus y dy? Did I tell you to think? D of x square plus y square, what that would be? So that would be nothing but 2x dx plus 2y dy. Did I tell you this particular scenario or not? That means sir, x dx plus y dy will be nothing but 1 by 2 d of x square plus y square. So what x dx plus y dy could be written as 1 by 2 of d of x square plus y square divided by x square plus y square. That is equals to d of xy divided by xy whole square. Now if you know some scenarios, what is the value of dt by t? If I integrate, what is the answer I will be getting? I will be getting the answer of ln t. What is the value of dt by t square? If I integrate, what is the answer I will be getting? So I will be getting the answer of minus 1 by t. Simple integration. Can you do these integrations or not? Can you do this integration? Sir, if I assume x square plus y square equals to t, so it will become dt by t. Sir, what is the meaning of dt by t? Sir, it will be ln t. That means if I integrate on both of the sides, if I integrate here, if I integrate here, so what answer I will be getting? Here, sir, I will be getting the answer of tan inverse y by x. First answer, I will be getting tan inverse y by x. Plus, what answer we will be getting here? Sir, it is dt by t only. Dt by t means ln t. So, plus 1 by 2 ln t, which is x square plus y square. That would be equals to what? If I solve it here, what answer I will be getting? So dt by t square will be nothing but minus 1 by t. What is t? T is xy. So minus 1 by xy plus constant c. There you go. This is the answer. That's it. This is the answer that you are getting. Is that understandable to you or not? A very, very good question and a very easy question as well. Not very easy, but if it is clicking to you in the examination hall, then it is easy. Otherwise, it would be difficult. So this is your inspection method. In the examination, hardly 1 or 2 questions have been asked from the inspection method, and they were very straightforward. Like very straightforward means this kind of question they will ask. Like y dx minus x dy divided by x square. Directly you are able to see here. Like this is actually self-framed only. I only framed this question. So this much difficult they will not go. But inspection, if they are asking, no, then make sure that x dy minus y dx. Just remember this table. Which table? This table that we have seen. Just remember this. X dx sorry, x dy minus y dx. Sir, minus sign is there. No, minus sign is there. X dy minus y dx. Sir, minus sign is there. Sir, this particular thing is not very straightforward. They have cousin brothers. Cousin brothers, they will be divided with x square or y square or xy or x square plus y square. When we divide with x square, d of y by x. When we divide with y square, d of x by y. When we divide with xy, then it could be ln y by x or ln x by y. When we divide with x square plus y square, then it could be tan inverse y by x or tan inverse x by y. These are the scenarios, and this is how you need to study that. This is how you need to use your intuitions. So this was your inspection method. Okay, and we also understood the meaning of integrating factor as well. So what all three methods we have studied? Let me know what all three methods we have studied. Like here, this minus 1 by xy could be taken to the left hand side as well. So what all three methods we have studied? Sir, variable separation, then sir exact equation, and then inspection. So what will be your way in the examination? Let's just say they have asked solve the differential equation, which was of the form m dx plus n dy. So first of all, you will see whether sir variable separation is possible or not. This is something that we have already studied in our class 12th. So variable separation will be clearly visible. Like it would be clearly visible. We have seen the examples. No, we have seen the examples. Variable separation would be clearly visible. There will not be any ambiguity that sir here directly you know that sir y will go here, x will go here. There will not be any ambiguity. Here also clearly it is visible. E to the power minus 2y clearly it is visible. So variable separation will be clearly visible. Now if the question is coming in this form, in which form? In this kind of form if the question is coming. So what you will think? First of all, you will check whether the equation is exact or not. Let's just say you calculated partial differentiation of m with respect to y, partial differentiation of n with respect to x. Equation came out to be exact. You will be very happy. Straightforward solution. No task there. Right? No pressure on the brain. You know how to solve an exact differential equation. So m dx plus n dy. M dx plus n dy. Can you apply inspection here? Can you solve it by the inspection method? Absolutely not, sir. So many times 2x square minus y square, 4xy, x square minus 2y square. Can I solve it with the inspection method? Absolutely not. With the inspection method, sir, it is nearly impossible to solve this equation. Right? So what will be the first thing that will be clicking to me? Variable separation? Absolutely not. How you will solve by variable separation? Can you take the term of x aside and term of y aside? No, sir. 2x square minus y square, 4xy, sir, all are added or subtracted. So it is not very straightforward as well. So what will click to you? Exact equation or non-exact equation? Sir, what if the equation comes out to be non-exact? That we will see. But if the equation is coming out to be on the exact way, then you will be able to solve, right? And then this inspection method. So here in the inspection method, yes, you need to do some work. Surely you need to do some work. If the question is coming m dx plus n dy, let's just say, sir, it is not clicking to me. First of all, what I will do? I will see whether the equation is exact or not. Equation will come out to be not exact. Then I will think of inspection method. I will try to make such form y dx. I will see that, sir, x dy y dx. Yes, I can get that particular form. I am telling you, if the question is coming from inspection method, no, then surely this will be visible. Y dx minus x dy or x dy minus y dx. If it is coming on inspection method, or at least x dy plus y dx will be visible. That could be written as d of xy. Okay, this would be visible. So inspection would work only on these kind of things, no, right? So these standard pattern that we have seen, no, they will be visible in your examination. All you don't need to worry about it. Understandable? Yes. So this is how you will be able to see that yes, I can apply the inspection method. Okay, understandable? Now, sir, if nothing is working, if all three of them are not working, then what I will do? Sir, I checked first. What I checked? That, sir, variable separation, no chance. Inspection, sir, no chance. When I calculated that whether the equation is exact or not, it came out to be non-exact now. So variable separation also I cannot do, sir. Exact equation also I cannot do. Inspection method is also not working, sir. Now what do I do? So when you are checking the exact equation, what was your equation? Sir, equation was m dx plus n dy equals to 0. So when I was checking whether it is exact or not, I would have calculated partial differentiation of m with respect to y, right? And also I would have calculated partial differentiation of n with respect to x. This is our type 4. 3 types we have already studied. This is our type 4. So when I was solving this particular equation, it came out to be non-exact. So I would have surely calculated the partial differentiation of m with respect to y and partial differentiation of n with respect to x. Now what I will do is that I will do one thing. I will subtract partial differentiation of m with respect to y, partial differentiation of n with respect to x. This is the subtraction I will perform, and I will divide this expression with whatever that is written in the end. What is written? N is written in the end. Now if it comes out to be a function of what is written here, x, only I need to see in the end. Sir, these two things I have calculated, I need to subtract them. In the end, what is written? N is written, so divided by n. Here what is written? Sir, x is written. So if it comes out to be a function of x, then my integrating factor would be nothing but e to the power this fx dot dx. That would be my integrating factor. What is the meaning of integrating factor? Sir, if I multiply this integrating factor on both of the side, what I mean to say is that, sir, if I multiply this integrating factor here plus integrating factor here equals to 0 into integrating factor. 0 into integrating factor will be 0 only, no? Integrating factor. If I multiply this integrating factor, then sir, this equation will come out to be exact equation. And if it is exact equation, then I can solve it. This equation will come out to be exact equation, and if it is exact, I will be able to solve it. 0 into integrating factor will be 0 only. So if I multiply the integrating factor on both of the side, this equation which was non-exact, it will come out to be an exact equation. And if it comes out to be exact equation, I can directly solve it because I have the method. Are you able to understand this point? So how will you remember that, sir, these two guys I have already calculated. I will subtract them. In the end, what is written? N is written. If it comes out to a function of x, then this will be the integrating factor. Now, sir, what if, sir, I do this calculation? This time I will write down n first and m later on. In the end, what is written? Sir, in the end here m is written, so divided by m. If it comes out to be a function of y, then your integrating factor would be e to the power fy dot dy. Is that understandable to you? Now let me tell you in the examination how the questions could be asked. So 90% chances are there that question would be coming from here only. If the question is coming on a first order differential equation, first order degree 1 differential equation, then 90% chances are there that question would be coming from here only. 90% chances. Okay. Now let's just say if the question is coming from, if a question is not solved by variable separation as well, you cannot solve it by inspection, and it is non-exact equation as well, then very higher chances are there that they will only ask integrating factor. They will not ask the full question. They will only ask find out the integrating factor, nothing else. They will not ask the solution. They will only ask what is the integrating factor. Write down the integrating factor. That's it. They will not ask the full question. They will only ask the integrating factor. If the question is coming from type 4, we will see type 5 as well, and we will see type 6 as well. There are 6 types. 90% chances are there that from first 3 types question will be framed. Now, if the question is coming from type 4 or type 5 or type 6, these 3 types we need to see now. If question is coming from there, then there is very high chance that they will be only asking the integrating factor. First of all, higher chances are there that question will not even come. If the question is coming, then they will highly, it is expected that they will ask only the integrating factor. Let's solve the question. It will be more clear to you. This is the question that is coming. Can you solve it with inspection? Yes. With inspection, yes, we can solve it. Right? Say yes or no. In the examination, if this question is coming, I will solve it with inspection, because it is clearly visible to me that x square plus y square dot dx plus 2x dx plus 2y dy. 2x dx plus 2y dy equals to 0. Now what I would do is that I would divide with x square plus y square. I will divide with x square plus y square. Let's divide it with x square plus y square. Here you divide with x square plus y square. Right? On both of the side I have divided with x square plus y square. Sir, what this will come out to be? This will come out to be ln x square plus y square. And sir, this will come out to be x only equals to constant. There you go. This is the answer. Okay. So this will be done. I guess this is the answer only. But yeah, mostly this is the answer only. सही है ना भाई? हाँ सही है. But let's hide it once. So we can solve it with inspection. But let's just say I don't want to solve it with inspection. So how will I solve it? So let's just say inspection is not even clicking to me in the examination hall. So what I will do? M dx plus n dy. M dx plus n dy equals to 0. Let's calculate partial differentiation of m with respect to y. So that would be 2y. Now partial differentiation of n with respect to x, that is coming out to be 0. Sir, both are not same. Both are not same. Now what do I do? What do I do? Now let's try doing this thing. Partial differentiation of m with respect to y divided by n. What answer you are getting? Sir, partial differentiation of m with respect to y, that would be 2y, minus partial differentiation of n with respect to x, that would be 0, divided by m, divided by n, divided by n. What is your n? N is nothing but 2y. N is nothing but 2y. So what you are getting? 2y by 2y. What is that? That is 1 only. You expected it to be a function of x. Yes, it is a function of x. Although it is a constant, but it is a function of x, no? Right? It should not be a function of y. That is the condition. It should not be a function of y. It is coming out to be a function of x. Yes, it is fine. So what will be your integrating factor? Sir, my integrating factor would be nothing but e to the power fx dot dx. So my integrating factor would be nothing but e to the power x. Now what you do is that you multiply with e to the power x on both of the side. Here also you multiply with e to the power x, e to the power x, multiply with x square plus e to the power x, multiply with y square plus 2x e to the power x dot dx plus 2y e to the power x dy equals to 0. Now this is your new m and this is your new n. This is your new m and this is your new n. Right? Now you calculate the partial differentiation of m with respect to y. Partial differentiation of m with respect to y. So what is the answer you are getting? 2y e to the power x, and then partial differentiation of n with respect to x. What you are getting? 2y e to the power x. Yes sir, it is coming out to be an exact equation, and sir, if it is coming out to be exact equation, then I am very happy. Then I am very happy. If it is coming out to be exact equation, then I am very happy. What I can do is that, sir, I can solve it very easily. Since it is exact, then what I will say is that I will remove this, I will remove this, and I will remove this as well. Here I will simply integrate, here I will simply integrate. Whatever the term which is related with x, put that to 0. Treat y as constant and solve it. So basically I am supposed to solve e to the power x, x square plus 2x e to the power x dx plus e to the power x y square dot dx. This is what I am supposed to solve, no? Equals to constant. This is what I am supposed to solve. Right? E to the power x dot x square plus 2x e to the power x dot dx plus, sir, y square will be treated as constant, no? Y square will be treated as constant. So y square you can take outside. And what is the integration of e to the power x? That will be e to the power x only, equals to constant. You are supposed to solve this integration. Can you think of it? What will be the answer? Can you think of it? Sir, if I just use my brain, although you can apply eyelet rule you can apply, but if just you use your brain a bit, then can you think that, sir, it is written nothing but d of x square e to the power x plus this is your y square e to the power x. Like basically this particular part I have integrated already. What is the integration of this part? Y square will be treated as constant, e to the power x, integration of e to the power x is e to the power x only. So this I have integrated. How did I write down this thing? Because I know that, sir, here what I will do, x square as it is, in differentiation of e to the power x will be e to the power x plus differentiation of 2x, sorry, differentiation of x square will be 2x and e to the power x as it is. There you go. This is something that I will be getting dot dx. This is something that I will be getting. So yes, I am getting the same thing. So this is how I can write it down. Again, I have used my intuition here. I have used the inspection. That, sir, it could be written as x square e to the power x. If it is not clicking to you, what you will do? You will apply the eyelet rule. First one as it is integration. First one as it is integration of second minus differentiation of first, then integration of second. Eventually, you will get this answer only, x square e to the power x. Like basically with the eyelet as well, you could have solved it. What I need to do? Let's solve this one. What answer you will be getting? Sir, first one as it is, e to the power x as it is, sorry, x square as it is, integration of second minus differentiation of first, integration of second, and then whole integration. This is what you are getting, right? When you solve by eyelet. When you solve by eyelet, this is what you are getting. Now there is this integration and then there is another integration which is in the plus sign, plus 2x e to the power x. So this and this will get cancelled out. Eventually what answer you are getting? X square e to the power x. So this was also very straightforward. Here needlessly you are using your intuitions and all. This was also very straightforward. You know that integration and d will get cancelled out. Answer is coming out to be x square e to the power x plus y square e to the power x equals to c. This is the answer that you are getting. Or you can do one thing, x square plus y square you take common, x square plus y square you take common, multiply with e to the power x equals to c. This is the answer that you are getting. Okay, so yes, this is the answer that we are getting. Is that clear or not? By the inspection as well, we were getting the same answer, no? By the inspection, here we were getting dx plus 2x dx plus y dy divided by x square plus y square equals to 0. This will be x ln x square plus y square equals to constant. And here we are getting x square plus y square e to the power x square plus y square e to the power s. Yeah, we are getting the same answer only. This is constant, no? So what I can do is that ln x square plus y square equals to c minus x, right? So if I take this ln this side, so what I will get? X square plus y square e to the power c minus e to the power c dot e to the power minus x. Now this e to the power minus x will come this side. So what answer we are getting? E to the power x square plus y square equals to e to the power c, which is a constant. So yes, this is the answer that we are getting. Same answer we are getting. So just you interchange some values and you will see that yes, we are getting the same answer by inspection method as well. If in the examination inspection is clicking to you, then congratulations. If it is not clicking to you, then this is the method that you can proceed with. Understandable? Well and good. Now here someone would say that, sir, you applied this method, no? Del m by del y minus del n by del x divided by n. Sir, what if I would have done this thing? What if, sir, I would have done the opposite? That means, sir, what if I would have partially differentiated n with respect to x? Same differentiation I am putting, but just that, sir, I am interchanging them. Divided by m. So, sir, what I will be getting? I am expecting it to be a function of y. Do I get a function of y? Let's check it. So, what is del n by del x? Sir, that is 0. What is del m by del y? That is 2y. Divided by m. What is m? M is, sir, x square plus y square plus 2x. Is it coming out to be a function of y? Absolutely not. It is not a function of y. It is actually a function of x comma y. Right? It is a function of x comma y. But it has to be a purely of a function of y only. If it was purely a function of y, then my integrating factor would have been e to the power fy dot dy. Right? But it is not coming out to a function of y. That's why we cannot apply this method. We have to go with del m by del y minus del n by del x. Understandable? Let's see the next question. Let's see this question. Look here, what is asked? Only integrating factor they are asking. They are not asking the full solution. Only integrating factor they are asking. So in the examination, if integrating factor they are asking, so you would know that, sir, inspection and all, nothing seem to work here. You can see the very 2xy to the power 4 e to the power y. Can you apply the inspection method here? Inspection, sir, will not work. Variable separation, no chance. X square, y square, everything is connected. So, sir, I will have to check whether the equation is exact or not. So what I thought was, let's check if the equation is exact or not. So partial differentiation of m with respect to y. This is my m, right? So I am partially differentiating it with respect to y. What answer I am getting? 8x y to the power 3. Okay, partial differentiation with respect to y we are doing, no? Partial differentiation with respect to y. So this will be treated as constant. 2x will be treated as constant. First one as it is. Plus 6xy square plus 1. This is what we are getting, right? So let me write it down in a good way. So 8x y cube e to the power y plus 2x y to the power 4 e to the power y plus 6x y square plus 1. Let me see. Simple differentiation, partial differentiation of m with respect to y, treating x as constant. X is treated as constant. Here also it was treated as constant. So 6y square, here e to the power y, 4y cube plus y to the power 4 e to the power y. This has become 2x y to the power 4, 8x y cube e to the power y plus 1. Yeah. So this is your partial differentiation of m with respect to y. Now partial differentiation of n with respect to x. So this should be differentiated with respect to x. So what you are getting? 2x y to the power 4 e to the power y minus 2x y square minus 3. This is what you are getting. This is your partial differentiation of n with respect to x. So first of all, what you will calculate? So the partial differentiation of m with respect to y, partial differentiation of n with respect to x divided by n. Is it coming out to be a function of x or not? This is what I need to calculate. So this minus this. What you will see? This thing and this thing will get cancelled out. Then this thing and this thing will become 8xy square. 1 minus 3 will become 4. So eventually what answer you will be getting? The answer that we will be getting it 8x y cube e to the power y plus 8x y square plus 4. This is the answer that we are getting. Divided with n divided with n, x square y to the power 4, wait a second, क्या कर रहे हैं भाई, wait, this and this is getting cancelled out, right, this and this is getting cancelled out, this is becoming 8, 1 minus 3, yes, simply I am subtracting them, nothing else, simple subtraction. I hope you are able to do it. Now I can directly see that, sir, are we getting anything out of it? I have divided it by n. Am I getting something common or anything like that? Nothing is happening, right? Surely it is not coming out to be a function of x. Are you able to understand this point? Like here, if you check, sir, my minus nx you have done. My minus nx you have done. So this is the answer you are getting. 8xy cube e to the power y plus 8xy square plus 4 divided with this m. Divided with n. So are you getting anything common or anything is being cancelled out? Nothing is being cancelled out. It is not coming out to be a function of x. So if it is not working, then what I will say? That this method will not work. What I will do? I will do the opposite. Nx minus my divided with m. If it is coming out to be a function of y, then I will be happy. Now let's check. Nx minus my. What will I have written? My minus nx, right? My minus nx I have already written. So what will be nx minus my? Simply the negative of this. So it would be minus 8x y cube e to the power y minus 8xy square minus 4 divided with m. What is your m? M is nothing but 2x y to the power 4 e to the power y. यहां से अगर मैं एक्स वाई कॉमन लेता, yeah, nothing, yeah, so 2xy to the power 4 e to the power y plus 2xy cube plus y, right? So now let's do one thing. From the upper side we will take y common. No, from the upper side we will take 4 common. From the upper side what we will take? We will take 4 common or minus 4 common. From the upper side we are taking minus 4 common. So inside what you will be getting? 2xy cube e to the power y plus 2xy square plus 1. And from the downward side what we will do? We will take y common. From the downward side we will take y common. So what you are getting? 2xy cube e to the power y plus 2xy square plus 1. And there you go, this and this is getting cancelled out. So eventually it is coming out to be nothing but minus 4 by y. That means yes, it is a function of y only. Not very straightforward. I know that, sir, nx minus my you would have done it. I would have written this expression and this expression. So now I will not be able to think whether it will be a function of y or not. So you will have to check that can you take something common? Yes, sir, I can take minus 4 common. Then, sir, inside this will be left. From here, sir, I can take y common. So this and this is getting cancelled out. Here you take anything common, nothing will get cancelled out. You can directly see, no, sir, here the constant term is 4 and here the constant term is 3x. How the things will get cancelled out? Here the scenario was, here it is 4, here it is y, I can take common. If I take y common, then things can happen. If I take x common here, can the things take place? If I take x common from here, and from upper side if I take 4 common, nothing. If I take 4 common, here 1 will be left, here minus 3 will be left. So eventually it will never come out to be a function of x. You can check as many times as you can. It will not come out to be a function of x. So what will be your integrating factor? So my integrating factor will come out to be nothing but e to the power f of y dot dy. So that would be e to the power integration minus 4 by y dy. So eventually let's write down on the next page. So my integrating factor is coming out to be e to the power minus 4 by y dy. This is what I am getting, no? 4 by y dy. So can you let me know the answer of 4 by y dy? Sir, it would be nothing but 4 outside ln y. Or can I write down it as ln y to the power 4? Yes, sir. So e to the power minus ln y to the power 4. Now I hope you know if there was a negative sign, if there was negative sign, if there was this negative sign, then this negative sign can go upward. So it could be written as ln y to the power minus 4, or it could be written as ln 1 by y to the power 4. So it could be written as e to the power ln 1 by y to the power 4. 1 by y to the power 4. And e and ln will get cancelled out. What is the answer? 1 by y to the power 4. So what is your integrating factor? Integrating factor is coming out to be 1 by y to the power 4. This is the answer that you need to mark. Okay, that's the answer. Is that understandable to you or not? Now, sir, will I be able to solve it? You can do it. If you want to do it, you can do it. It will come out to be an exact equation. If you want to solve the equation, then what you need to do is that you need to multiply with 1 by y to the power 4 on both of the sides. So what answer you will be getting? 2x e to the power y. Here you will be getting 2x e to the power y plus 2x by y, 2x by y plus y 1 by y cube dot dx plus x square e to the power y. I am just simply multiplying with 1 by y to the power 4, multiplying with 1 by y to the power 4, minus x square by y square minus 3x by y to the power 4 dot dy equals to 0. Now you integrate and you integrate. What will happen? Here treat x as here whatever the term which are related with x, they will be going to 0. Function of x will be going to 0. Function of x will be going to 0. So everything will be 0. This will come out to be constant. What about this thing? Here you need to treat x square e to the power y plus x square by y plus x by y cube. What you need to do? You are integrating with respect to x, right? So what you are doing? 2 e to the power y outside, x square by 2. So e to the power y x square. Then you will take 1 by y outside. So it will be x square by 1 by y. And then you will take 1 by y cube outside. Integration of dx would be x only. So x by y cube plus constant equals to 0. That's it. Plus constant equals to constant, or you can simply say equals to constant. Because this is also 0, this is also 0, constant, it will come out to be equals to constant only. So this is the solution. So in the examination, yes, they can ask the solution as well. But the more important part would be that there are very higher chances that they will ask the integrating factor. Solution will be a cakewalk. You know that, sir, if I multiply with 1 by y to the power 4, if I multiply with 1 by y to the power 4, so it will come out to be an exact equation. And if it is exact equation, then I can solve it using my basic concepts. Right? So simply multiplying with 1 by y to the power 4, these are the answer I am getting. 1 by 2x e to the power y, 2x by y plus 1 by y cube dx and so on. Okay. Okay. Now type 5 we need to see. So sir, question came m dx plus n dy. This question came, sir, equals to 0. This question came, sir. Sir, I applied variable separation. Sir, I saw that variable separation is not working. Let's just say this question is there. This question is there. Sir, variable separation, absolutely not. Inspection, absolutely not. Variable separation, not working. Exact equation, I checked that, sir, it is not an exact equation. I checked that it is not an exact equation as well. Then, sir, I checked this particular thing. It was not coming out to be a function of x. Then, sir, I checked this particular thing as well. What I checked? Nx minus my. Nx means partial differentiation of n with respect to x. Partial differentiation of n with respect to x minus partial differentiation of m with respect to y divided with m. It should be a function of y, but sir, this also was not happening. So all four things were not happening, sir. All four were. This was also not happening. So sir, nothing is working. What do I do now? Nothing is working, sir. What do I do now? Then there are very high chances that they would be asking you the integrating factor. Sir, it is non-exact. It is non-exact. Sir, variable separation is not working. Sir, your variable separation not working. Sir, inspection is not working. It is non-exact. And sir, this thing I tried, this is also not working. What do I do now? Then what I will do is that I will be examining m and n. What I will be examining? M and n. So m and n both will be a function of x comma y, no? Both will be a function of x comma y. Both will be a function of x comma y, x comma y. Now, if they are homogeneous function, do you remember what is the meaning of homogeneous function? If they are homogeneous function, at least 2 times we have studied already. In the whole engineering mathematics course, we have already studied the meaning of homogeneous function at least 2 times. Right? If they are homogeneous function of a same order, if they are homogeneous function of a same order, then something I can do. Now what is the meaning of homogeneous function? If you remember it, what we need to do is that we need to put in place of x we need to put kx, in place of y we need to put ky. Same I will do with the function n as well. Now what will happen is that, sir, some k to the power n will come outside. It could be k to the power 0, it could be k to the power 1, it could be k to the power 2, it could be k to the power 3, 4, 5, whatever it is. Some k to the power n should come outside, and this is something that we should be getting. If this is the scenario, then sir, something could be done. Something could be done. What could be done? What could be done is that we will get an integrating factor, and that integrating factor would be nothing but 1 upon m into x. It is not mx, it is m into x plus n into y. There you go. This will be the integrating factor, and this could be also asked in the examination. Don't worry, I will give you good enough technique to remember the things. Don't worry, as of now you just need to understand the concept. The concept is, sir, first I tried with the variable separation, did not work, sir. Inspection also not working, sir. It was not an exact equation. Then, sir, whatever the value that I calculated, del m by del y, del n by del x, then, sir, I tried to get the function of x, function of y, sir. This also it was not working. Now, sir, what do I do? So then you see m and n, if they are homogeneous function of same order, like here also power n should come outside, here also power n should come outside. If they are homogeneous function of same order, then your integrating factor would be 1 upon m into x plus n into y. So this has been written here. With the surely this condition should be satisfied that they should not be equal to 0. If they are equal to 0, then 1 by 0 that would make infinity, right? So should not be equal to 0. Now let's see one thing. If this question is coming that you need to solve the differential equation, you need to solve this differential equation, you need to find out the integrating factor, or you need to solve it. This question is coming. What you will do? First of all, inspection, is it working? No. Variable separation? No. Sir, is it exact equation? Let's try. Is it exact or not? So what is your m? This is your m. Partial differentiation of m with respect to y. What you are getting? Partial differentiation of m with respect to y. You are getting x square minus 4xy. Now partial differentiation of n with respect to x. What you are getting? 3x square minus 6xy. So surely it is not a exact equation. So it is non-exact. Now, sir, if it is non-exact, no, then one more thing I will try. Partial differentiation of m with respect to y minus partial differentiation of n with respect to x divided by n. Let's see if it is coming out to be a function of x or not. Let's see if this is happening or not. So let's see. Partial differentiation of m with respect to y, x square minus 4xy minus 3x square plus 6xy divided by n, which is coming out to be x cube minus 3x square y. So what answer you are getting? Sir, it is minus 2x square plus 2xy divided with, let's just say if I take x common, so what I will be getting? Or if I take x square common, or whatever, if I take x common, so what I am getting? X square plus 3xy. There is no chance that it is coming out to be a function of x. So, sir, it feels like that the method 4, the type 4, this type, which type? This type 4. This type 4 also feels like that it might not be working, right? Because, sir, this thing is not working. Now, next what I will try? Next I will try del n by del x minus del m by del y divided with m, if it is coming out to be a function of y or not. So I will check that. So I already know what will be the subtraction. The subtraction would be minus x square plus 4xy minus x square plus 4xy plus 3x square minus 6xy divided by m, x square y minus 2xy square minus 2xy square. Surely it will not be a function of y as well. So, sir, type 4 is also not working. That means the type 4 is also not working. Then what I will check? I will examine m and n. What is m? Sir, m is x square y minus 2xy square. X square y minus 2xy square. What is n? I know that you might be feeling a bit tired, right? First of all, here there is negative sign. No, okay, I mashed it up actually. Del n by del x would be having negative sign and this would be having positive sign actually. So this will become 4x square minus 10xy, 4x square minus 10xy, and eventually this will come out to be 10xy minus 4x square, 10xy minus 4x square. Surely it will not be a function of y. This is the only important point. This is not a function of x, this is not a function of y. You might be feeling a bit tired that sir, so much of calculation we will have to do in the examination. You will not have to do so much of calculation. I will tell you technique, but have some patience. Now what is your n? Your n is minus x cube plus 3xy square. Because what is the standard equation? Standard equation is m dx plus n dy. M dx plus n dy. That is the standard equation, no? That is the standard equation. So what is the value of n here? A value of n is minus x cube plus 3x square y. So minus x cube plus 3x square y. That is the value of n. Minus x cube plus 3x square y. That is the value of n. Right? Now here in m what I will do? In m what I will do is that in place of x I will put kx, in place of y I will put ky. So what you will be getting? K square x square in place of k square x square dot ky minus 2, in place of x I will put kx, k square y square. So what I can see, sir, k to the power 3 is coming outside, x square y minus 2x y square. That means this is coming out to be nothing but k to the power 3m. That means this is a homogeneous function of order 3. Eventually it is homogeneous function of order 3. And similar thing, this is also a homogeneous function of order 3. You can directly see that, sir, if in place of x if I put kx, in place of x if I put kx, in place of y if I put ky, k to the power 3 will come outside. So sir, this is also homogeneous function of order 3. And if both are homogeneous function of order 3, that means both are homogeneous function of same order, then my integrating factor would be nothing but 1 upon mx plus ny. Mx plus ny. This will be my integrating factor. Okay. So what is the value of m into x and plus n into y? So m will be, this particular thing will be multiplied with x. So what you will be getting? X cube y minus 2x square y square, minus 2x square y square. Then n into y. So this will be minus x cube y plus 3x square y square plus 3x square y square. What you are getting? This x cube y is getting cancelled out. 1 upon x square plus y square. 1 upon x square plus y square. This is the integrating factor that you will get. So this is my integrating factor. This is my integrating factor. That is coming out to be 1 upon x square plus y square. There you go. This is the integrating factor that we are getting. Okay, so in the examination, most probably they will ask this question only. What is the integrating factor? So just let me know one thing. If this question is coming in the examination hall and they are asking you integrating factor, will you do this calculation? Will you do this calculation? Like what is easy to check? Is it easy to check type 4 or is it easy to check type 5? This is your type 5, no? From here onwards your calculation of type 5 is going on. For sir type 4, what I need to do? I need to partially differentiate, then sir I need to subtract and then check if it is coming out to a function of x. Then sir I will check this if it is coming out to a function of y. Then sir I will be able to tell it is not type 4. But sir for type 5, it is very straightforward. No sir, it is x square y. So from here k to the power 3 will come outside, k to the power 3 will come outside, k to the power 3 will come outside, k to the power 3 will come outside. Job done. It is homogeneous. Like within seconds I can check if it is homogeneous. And if it is homogeneous, you can apply this one. There you go. So my question is that in the examination, will you be checking type 4 first or you will be checking type 5 first? Type 5 is easier or type 4 is easier? This is your type 5. And what was your type 4? Type 4 will take this much of calculation. So which you will check first? Type 4 or type 5? Sir, I will be checking type 5 first. Okay? Because checking type 5 is easier for me. Why it is easier for me? Because sir, it is straightforward. I can directly see if it is homogeneous function or not. Yes, it is homogeneous function. It is also homogeneous function. Job done. What is the integrating factor? This is the integrating factor. Now we need to solve this equation. Now let's see the solution. So from solution, some interesting points will come out. Okay. From the solution onwards, some interesting point will come out. So let's see the solution. Let's solve the equation. Solve the equation now. What you need to do, you need to multiply the integrating factor on both of the side. So what I will do is that I will multiply the integrating factor, which will be 1 upon x square y square. So x square y minus 2x y square, x square y minus 2x y square, x square y minus 2x y square divided with, multiply with 1 upon x square y square, 1 upon x square y square, 1 upon x square y square. Minus x cube plus 3xy square, minus x cube plus 3xy square divided with x square y square, x square y square. Equals to 0. Okay. X square y minus 2xy square. This minus sign I have taken inside. So plus minus x cube plus 3x square y. Minus x cube plus 3x square y divided by x square y square, x square y square. Yeah. So what answer you are getting? 1 upon y minus 2 by x, 1 upon y minus 2 by x dot dx plus minus x by y square plus 3 by x dot dy equals to 0. So it is your m dx plus n dy equals to 0. So partial differentiation of m with respect to y will be minus 1 by y square. Partial differentiation of n with respect to x क्या बात है भाई, partial differentiation of m with respect to y is giving you minus 1 by y square. Partial differentiation of m with respect to x is giving you minus 1 by y square minus 3 by x as well. 3x square y. It was 3x square y. Sorry guys. It was 3x square y. It was 3x square y. So x square y. So this is coming out to be 3 by y. So yes, partial differentiation of m with respect to x, partial differentiation of m with respect to y is giving you minus 1 by y square, and partial differentiation of n with respect to x is also giving you minus 1 by y square. That means yes, it is exact equation, although it is not required to check, because this is the meaning of your integrating factor, that it will make the equation to be exact equation only. So yes, it is exact equation. What I need to do is that if it is exact, I can simply integrate. How will I integrate? I will integrate in a way that, how will I integrate? 1 by y minus 2 by x dx plus minus x by y square 3 by y dy equals to constant. Okay. So here what I will do, whatever the term which is related with x, that would be put down to 0. This will give you 3 ln y. What it will give you? X by y minus 2 ln x plus 3 ln y equals to constant. There you go. This is the answer. Right? Integration of 1 by y will be x by y minus 2 ln x plus 3 ln y equals to constant. This is the answer that you are getting. Okay. So in the examination, what if they were asking this question that you solve this differential equation? Will you be solving, will you be doing all this process and everything? No. What I will do? Sir, first of all, I will check whether the equation is homogeneous or not. Homogeneous, very easily I will be able to check. Sir, power 3 is coming outside. Yes, it is homogeneous. If it is homogeneous, then sir, directly I can write down the integrating factor very easily. Then directly I multiply. I will not even check this particular thing. I will avoid these two steps. Is it necessary? No, because I know that sir, if I am multiplying with 1 by x square y square, then surely it will be exact only. Without even checking, I know that it will be exact equation. So surely I will directly solve considering it exact equation, and I will get the answer. Now there is another method, method 2, which will work only for homogeneous equation. Method 2 for homogeneous equation. Homogeneous m and n. if they are homogeneous, then there is method 2 as well. So let's rewrite our question. What is our question? That we need to solve this differential equation. Let's rewrite it. So I got to know that yes sir, these m and n are homogeneous. This guy is also homogeneous and the other guy is also homogeneous. This I have already understood. Both of the guys are homogeneous, right? Now if both of them are homogeneous, then what I can do, find out dy by dx. What you do is that find out dy by dx. So what will be the value of dy by dx here? Like you take this one aside. So what you will be getting, x square y minus 2xy square dx equals to x cube minus 3x square y dy, right? And then you simply divide them. X cube minus 3x square y. Is that understandable to you or not? If you just multiply here, what you will be getting? This term you will be getting. If you multiply this here, if you multiply this here, then what term you will be getting? This term you will be getting. And simply subtraction of both of them equals to 0. So this is how I can replace it, no? This is how I can replace them. Right? Now I know that sir, this is also homogeneous function of order 3. This is also homogeneous function of order 3. Now what I do is that on numerator and denominator I am dividing with x cube. Why I am doing so, you will understand. What I am doing on numerator and denominator I am dividing with x cube. Divided with x cube. Divided with x cube. Then x cube divided with x cube minus 3 x square y divided with x cube. Now x square y divided with x cube, what you will be getting? Sir, this is coming out to be y by x minus 2x. This is coming out to be x and x will get cancelled out. So 2 of y by x whole square. Y by x minus 2 of y by x whole square. Y by x minus y by x minus 2 of y by x whole square divided with x cube by x cube will be 1 only, and x cube x square x cube, so this will become 3 of y by x. Is that understandable to you? So your dy by dx is coming out to be equals to this thing. Say yes or no. So what I can do is that I can keep y by x equals to v. Like directly I can see, no, that this is a separate factor, y by x factor I am getting, and it is pretty obvious as well. Like, did you understand why I divided with x cube only? Because I know that sir, I need to make a form of y by x. So here if I divide with x cube, I will get a y by x form. Here I will divide with x cube, what I will be getting? Y by x whole square. Here I divide with x cube, it will become 1, and here I will be getting y by x again. So y by x equals to v I can put. So what is your y? Y is coming out to be vx. Now from here, can I calculate dy by dx? Yes sir, dy by dx. This is your u into v function. So first one as it is, differentiation of second, differentiation of x will be 1, plus second as it is, differentiation of v will be dv by dx. So dy by dx could be replaced as v plus x dv by dx, and that is coming out to be equals to, what is y by x? Y by x is nothing but v. V minus 2v square upon 1 minus 3v. 1 minus 3v. Is that understandable to you? Now what I can do is that from here x dv by dx is coming out to be v minus 2v square upon 1 minus 3v minus v. So what you are getting, x dv by dx would be equals to v minus 2v square minus v plus 3v square divided with 1 minus 3v. Right? This is v minus 2v square divided by 1 minus 3v minus v. So minus v plus 3v square. So this and this is getting cancelled out. What answer you are getting? V square 1 minus 3v. So x into, I need to add a page. What you are getting? X into dv by dx. X into dv by dx is coming out to be, x into dv by dx is coming out to be v square minus 1 minus 3v. Now variable separation can work. From here variable separation can work. Variable separation can work. Say yes or no. How it can work? So it will be simply 1 minus 3v by v square into dv equals to dx by x. So 1 by v square minus 3 by v dot dv equals to dx by x both side you integrate. What is the integration of 1 by v square? That is minus 1 by v. This will come out to be minus 3 ln v, and this will come out to be ln x, right? Plus c. Let's see. What is the value of this? Is ln v. Sorry guys, this is ln v. What is the value of v? Sir, y by x was v, right? y by x was v. So what is the value of v? Value of v is y by x. So this will become x by y, 3 ln y by x equals to ln x plus c. This is the answer. Or what you can see here is that minus x by y minus 3 ln y plus 3 ln x equals to ln x plus c. So in what way we wrote the answer? In this way we wrote the answer. So what we will do is that we will take this ln x aside, or what we will do is that we will take all of them this side and constant to the other side, So what answer we will be getting? X by y. From here, what answer will be getting? X by y minus 2 ln x plus 3 ln y equals to some constant c. Let's call this constant as k. This constant as k. This constant is k. This constant will come out to be c. This is the answer that we are getting. X by y minus 2 ln x plus 3 ln y. X by y minus 2 ln x plus 3 ln y equals to constant c. Same answer we are getting. Is that understandable to you or not? So this is your new method of solving homogeneous equation. So whenever you see homogeneous equation, if you feel like that, sir, I don't want to think of integrating factor or anything, directly what you will do? You will calculate dy by dx. You will make a form of y by x. If you are able to make a form of y by x, your job is done. Okay. Then simply you solve in this manner. Just after that, everything is calculation. Nothing difficult here. Everything is calculation. You will get the answer. Try solving this question. If this question is coming in your examination hall, will you be checking first that whether it is exact equation or not? Let's just say I try to check exact equation. Partial differentiation of m with respect to y. What is the answer we are getting? 2y. Partial differentiation of n with respect to x. What is the answer we are getting? 2x minus y. This is the answer we are getting. Right? Now you can check that my minus nx upon n, which will be 2y minus 2x plus y divided with n, which is x square minus xy. So x you can take common, x minus y, and this is your 3y minus 2x divided with x upon x minus y. Surely it is not a function of x, and similarly it will not be a function of y as well. All these things I will not even have to check. What I can see is that this is, sir, homogeneous of degree 2. This is also homogeneous of degree 2, because in place of x if I put kx, in place of y if I put ky, k square is coming outside. Here also k square is coming outside. Both are homogeneous function of same degree. Both are homogeneous function of same degree. Sorry, not degree, same order. Homogeneous function of order 2. That means what will be my integrating factor? If this is the method 1 I want to use, what will be my integrating factor? Sir, my integrating factor will be nothing but my integrating factor will be nothing but 1 upon mx plus ny. So 1 upon m into x. So it will become x cube plus y square x plus x square y minus xy square. So what answer you are getting? 1 upon x cube plus x square y. Xy square, x square y. This is the integrating factor you are getting. So in the examination, this simple question they can ask, what is the integrating factor? Or basically they can frame the question in this way, that the given equation is non-exact. With what factor? With what factor you need to multiply this equation such that the equation becomes an exact equation? This question also they can ask. The given equation is non-exact. You need to multiply with what factor such that it becomes an exact equation? Then answer will be, sir, if you multiply with this factor, equation will become exact equation. Now let's just say in the examination they are asking the solution of it, that solve this equation. So can you solve this equation now? Sir, I need to multiply with this factor now, right? We have calculated in a correct way. What you need to multiply with? You need to multiply with this factor, which is 1 upon x cube plus x square y. This is what you need to multiply with. So what you will be getting? X square plus y square upon x cube plus x square y dot dx plus x cube minus xy upon x cube plus x square y dot dy equals to constant, because if we are integrating it equals to constant. I know that, sir, it is exact equation. I already know that it is exact equation. So, sir, all the terms, this is also related with x, this is also related with x, related with x, related with x. So this will go to 0. I don't have any issue. Can you solve this one very easily? Is it very straightforward? Solving this is very straightforward. Like, you need to solve this integration keeping y as constant. Keeping y as constant, you need to solve the integration x square plus y square upon x cube plus x square y. Not very straightforward, no. It is difficult to solve, right? Calculative. This particular integration will be calculative. 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 Now, if it is calculative, that means, sir, in the examination, if they were asking integrating factor, my job is done. But what if they are asking the solution? This is coming out to be calculative. So what I will do now? I will not go with method 1. I will go with method 2 now. I will go with method 2. So what is the answer you will be getting? Dy by dx. What will be your dy by dx? So dy by dx would be x square plus y square divided with xy minus x square. Xy minus x square. Say yes or no. Is it same? Look, I have taken this aside. Dy by dx I need to calculate. So this goes downward, xy minus x square and x square plus y square. This much calculation you can do on your own. Right? Now what I need to make? I need to make the form of y by x. So I will divide with x square in the numerator and denominator. If I divide with x square in the numerator and denominator, what I will be getting? Y by x whole square divided with y by x minus 1. Divide with x square in the numerator and denominator. So this will be 1 plus y by x whole square plus this will be y by x minus 1. This is what we are doing. Now, what I will do? Y by x equals to v. So y equals to vx dy by dx. First one as it is, differentiation of second one as it is, differentiation of first. So v plus x dv by dx equals to 1 plus v square upon v minus 1. X dv by dx x dv by dx equals to v square plus 1 upon v minus 1 minus v. So what answer we are getting? V minus 1, v square plus 1 minus v square plus v, right? V square plus 1 minus v, v minus 1. So v square plus 1 minus v square plus v. Yes. Plus v plus 1 upon v minus 1. So what you are getting when you solve it, what you are getting? V plus 1 upon v minus 1. V plus 1 upon v minus 1. Right? V square getting cancelled out. V plus 1 upon v minus 1. So x dv by dx equals to v plus 1 upon v minus 1. So what answer you are getting? V minus 1 upon v plus 1 dot dv equals to dx by x. V minus 1 upon v plus 1 dot dv equals to dx by x. This is what we are getting. Right? Can you solve it now? Both sides you need to integrate. Both sides we need to integrate. But let's try solving it here only. So what we will be getting is that we can write it down as v minus v plus 1 minus 2. V plus 1 minus 2 upon v plus 1 dot dv equals to dx by x. V plus 1 minus 2 divided by v plus 1 dot dv equals to dx by x. So what is the answer you are getting? 1 minus 2 upon v plus 1 dot dv equals to dx by x. Both sides you integrate. So dot dv, it will be v minus 2 ln v plus 1 equals to 1 by x will be ln x. That's it. Job done. Okay, let's check the calculation again. X divided by dx, v plus 1, v minus 1, v minus 1 upon v plus 1, v plus 1 minus 2, v minus 1 upon v plus 1. So 1 minus 2 upon v plus 1 dot dv dx by x. When you integrate, this is the answer that you are getting. That's it. What is v? V is y by x. Just put it. Y by x minus 2 ln y by x plus 1 ln x plus c as well. Plus c as well. So y by x minus 2 ln, look here what I can see, this will become y plus x divided by x. So y plus x minus ln x equals to ln x plus c. So what you are getting, y by x minus 2 ln y plus x plus ln x equals to c. That's it. This is the answer that we are getting. Okay, job done. This is the answer that we have. So this is how we can solve homogeneous equation. So this was your type 5. Now one more type is left, which is type 6. Final type is left, which is type 6. That we will see in the next lecture. Don't worry too much, just revise the notes again. Whatever that has been written in the notes, no, just revise it once again. You will not feel like very difficult. That's how to remember all these things. Like I have tried to break it down in the best possible way. That first we saw the variable separation, inspection, exact equation. If it is non-exact, then we have 3 types. This is type 4. This particular thing we will do. Partial differentiation of m with respect to y minus partial differentiation of n with respect to x divided by n. This particular thing we will do. If it is not working, or before that as well, we will see if the m and n are homogeneous or not. If n and m are homogeneous, if they are asking integrating factor, very easy for me. Integrating factor will be very easy for me. And if they are asking me to solve, then I would go with the method 2. This will be my better method. Here what I need to do is that I simply need to make the form of y by x equals to v, job done. After that, simple, it will be simply made in the form of variable separation method. So variable separation will be very straightforward. I will be able to solve. Similarly here as well, was it homogeneous? Yes. If they are asking integrating factor, mx plus ny, job done. If they are asking to solve the equation, then I will go with the method 2. This is how I will be solving it. Method 2 will be y by x I need to make, then y by x equals to v, and I will get my answer. Okay, so yes, simply keep on doing the calculation and you will get your correct answer. Okay, I hope calculation is completely correct. There is nothing wrong here. V minus 1 upon v plus 1 dot dv dx by x, v plus 1 minus 2, 1 minus 2 upon v minus v, v minus ln v equals to ln x, ln v plus 1. V is y by x, 2 ln y by x minus ln x minus 2 ln x plus 2 ln x minus ln x equals to c. Yeah, that's it. So next we will see type 6 as well. One more type is there. In this type 6, what will happen is that x will come outside, y will come outside. Like basically it will come out to be y multiply with function of x comma y equals to dx plus x multiply with function of x comma y dot dy equals to 0. So for this, what will be the integrating factor? That will be mx minus ny. Just a negative sign will come. So that we will see in the next lecture. Okay, and then we will see that if the question is coming, what will be my plan? How I will be thinking. That first I will go with variable separation, then I will think of inspection, then I will think of exact. If it is not exact, then how I will be thinking. So all the plans also we will see. Let's meet in the next video. Thank you very much.